Very good evening, class. Can you guys hear me? Let me know in the chat. Very good evening, Nilanjan. So yes, how are you guys? Very good evening, Arad. Oh yes. Yeah, same here, Nishant. I'm also like very excited to start this new like content as well. So I was on like after completing that Node.js batch, I just enjoyed that 10 or 12 days vacation. I went to like visited some of the places near to my place only, like Rajasthan or Lucknow. Spent some time with friends also. Watched Brahmastra movie as well. So yeah, so happy to back and talking with you guys again. Very happy. Yeah, I think, but people are like only 12 people I can see, 12 or 13 has joined. It should be more than I think, like when we were in the Node.js batch, we were seeing like more than 30 or sometime it's 40 as well. Is it because of Friday? People are enjoying? Or the batch like the number of students only that much only? What do you guys say? Vedant, I think you are here to take the class. Yes, thanks. Same here, Nana. I'm so very excited to talk to you guys again. Yes, Sanvas. Hello, Joseph. Hello, Nishant. What happened with Ankit? I remember like some of the name I remember. Ankit was there, and yeah, Nilanjan already remember, and Shweta was there, right? Shweta, yes, Ekta. Sorry, Ekta. Yes, I just take the name of Ekta, and she has also joined. So yeah. So how you guys are doing? Navneet. So yes, I'm seeing I think first time Navneet. Arad I know from the last batch. So what was that like after completing the module? How was the test, guys? I didn't got chance to ask that test. Yeah, Suraj. Hi, hey, good evening, Suraj. Hey, Ekta. It was good. Yeah, thanks. So yeah, it was good, right? You guys were able to answer most of the questions there. Hey, Nazmeen. Very good evening. Oh, great. I'm very happy to hear that. I remember some of the people has connected to me after the class also. Hey Ankit, yes, I was just asking like I didn't see till now like Ankit has joined, so I was asking like so people are joining or not. Yeah, I'm doing great. Ankit, thanks for asking. Very good evening, Vishal. Yeah, thanks. So yes, I think so. This actually data structure is very, you know, it's very difficult subject. When I was in college, so when the teacher was teaching me this subject, so everything was going up when I was in the class. I was just looking for like how can I pass this exam? Like after 3 months, they will be having some exams, right? So I was just thinking how could I pass because my faculty was not good. The real later on I realized that my faculty was not good. So that's why I was having that fear for the data structure. But if you have good faculty and like you understood the data structure in a real life examples ways, so I think this subject is not that much difficult which people generally feel. And you know one more thing, like the books also, like if you will read about the data structure in books, they are also not very easy to understand. I like in my college time I have taken some books from the library to understand the data structure part. So those books are also very really tough to understand, and some of the videos that in the I was in the, I think, 2014. So at that time on the YouTube also, or in the Google, like simply in internet, there was not good content also to understand some of the data structure concepts. So that's why I feel very difficult while I was in the college. But yeah, after college, I think when I started, so first thing after college, I realized that data structure is very important, because in all the big companies, they are asking a lot of questions from the data structures, specifically tree. When we talk about the tree, they, a lot of companies are asking question on tree or linked list, right? But yeah, their favorite option is tree, and then they go for linked list or other data structures, right? And guys, these like searching algorithms or sorting algorithms, these are very common algorithms. Once you will understand, like see, once I also started understanding data structure. Hey Parag. So I also started with first understanding the searching algorithm, then sorting algorithm, and after that I started understanding the data structure. So as you guys will also do the same. First understood these searching algorithms, then understood the sorting algorithms. I think the course also they have created in the similar way. They are first are teaching you the searching algorithm, then they are teaching you the sorting algorithms, and after that, I have not seen the course, full course. So, but after that, I think you should try to understand all the data structures also, like stack, queue, and tree and B tree, these data structures. So once you will understood these data structures and these searching and algorithms, and then you can directly jump into the questions, like the problems which generally we have in the data structures. Okay, guys. So that's how I started, and I think you guys can also follow the same. So first start with searching, and then you guys can go for sortings, and then you guys can understood the uh, data structures. And once you understood all three things, see, in one go you cannot understand everything. You cannot understand everything, or you cannot be like perfect in one go. So you have to do little bit practice. And these searching and sorting algorithms, most of the time I have seen you will use these searching algorithms or sorting algorithm in some of the problems. In the interviews, I have not seen till now anywhere they are asking to you to write any searching algorithms or sorting algorithms. I have not seen. I have seen, like I have in some of the interviews I have heard about quick sort or quick sort, specifically quick sort algorithms. But still, people does not ask you to write code. It's very rare where they are asking you to write code about it. They just simply want to understand, did you know how the sorting algorithms or how the searching algorithms are working? They just want to understand, those things or not. That's what. Because why not? Because right now we are using languages, right? Like JavaScript, Java, Python. We are using these languages, and these languages automatically has already used these data structures and algorithms. Like in the JavaScript, if you want to filter it out, if you want to search something from the array, you will use filter there. If you want to use sorting, you can simply do dot sort, right? Same goes in Python, same goes in Java. So that's why nobody is going to ask you to implement these things. They just want you to know that, what is happening on the background when you are using any languages. Okay, but in the real life, or if you are working on any project, it, like I have not used any of the algorithms till now. I am just directly using those methods till now. If I want to use, like if I want to search any element, I'm just using filter or the find index or the contains. These methods I'm using, right? Same goes for sorting, like in the JavaScript, because I am working from the starting in JavaScript. So JavaScript also provides the dot sort method. So I'm just simply using dot sort method there to sort my array. So that's why, guys, all the things which we are right now like reading or understanding here, these all things are happening on the background. Okay, if you talk about any real-time projects, so at that time all these things is running on the background, because you are using a language and language has already implemented them internally. So you guys don't need to write these things. So now where we will use these things? So these things will be used only in the interviews. I have personally seen only in the interviews, or you guys are doing any research in any of the new topics, like right, a lot of research is going on blockchain or in the machine learning, right? If you are doing any research project, then also you guys might be implementing something new, right? Some new language might be you guys are implementing. So on those places, you might need to use these algorithms or these searching or sorting algorithms to best optimize, like to get the best results. So that's why only in these two places, I personally feel you guys are going to use these searching and sorting algorithms, like in interviews. Or why in interviews? Because in interviews they ask you a lot of problems, right? So while solving those problems, you might need to use the searching algorithms, or might needs to use some of the sorting algorithms. Okay, guys. So these are the use cases, like in the real time, when you where you might face the problems or like questions on these topics. Okay, guys. So let's see some of the queries I is coming here. So let's see. Meanwhile, then. Uh, Joseph Parag. Yes, sir. That's why we missed your presence during the previous few classes. Amazon, they asked me searching questions which I was unable to answer at that time. They asked me searching questions. Oh, okay, yes, that's what I'm saying. In Nishan, so in the questions, definitely they are going to ask. Like I remember, there is very nice question in array which was pair sum. Like they will provide you one array, and you need to and they will provide you one target. Like there is one array, and they will provide you one target, and they will ask you. Like give me two numbers from that array. If we add them, then target should match. सी वेरी सिंपल प्रॉब्लम. एक एरे है, उसमें 5 एलिमेंट्स हैं, ठीक है. अब उन्होंने हमें टारगेट दे दिया. दे हैव गिवन मी टारगेट, एंड द टारगेट कुड बी एनी नंबर लाइक 12. So now they are asking me that could you please provide me two numbers from the array. If we add those numbers, I should get the target, and the time complexity should be very minimum. It should not be n square. So these type of questions, once, see, this is one question which I have faced many times. So that's why I remember this question. So in these type of questions, I think these searching algorithms could help us there. Okay. So need to understand recursion and its example with some coding. Sure, Nilanjan. So I think today we will see one. We'll try to implement one of the searching algorithm with recursion also. Okay. It's not difficult. We will try to understand the recursion also. Okay. So Sandwas is saying, uh, Hariharan, thanks, Hariharan. It's a good evening. I am not sure you are in US shift or what. Okay. So let's move further. Can we use include method to find reference data type in array? Can we use includes method to find reference data type in array? Uh, hmm. Let's try to understand what Sandwas is asking. He's saying, can we use include methods to find reference data type in array? I didn't understand the proper question. So we can talk more about it. Okay, later, Sandwas. I didn't understand properly the question, what you're asking here. Ashwin is saying, very good evening, Ashwin. Pair sum is a famous Google problem. Yeah, I think it's a famous problem. That's right. Niranjan, okay. Mostly asked question come from linked list tree, as you told. Yes, actually, I have seen like mostly asked question they ask in trees, because tree, I personally feel once you will understood the tree part, so like you can lost there, because tree is so complicated. Complicated means complicated and interesting. If something is complicated, I think it's interesting also for some people. So sometimes, yeah, trees like actually we can get a lot of questions. Okay, let's see. Somebody wants to raise hand. I think it's Ravina. So let's invite. Yeah, Ravina, can you hear me? Okay, now she has declined the invite. Okay, might be mistakenly she has asked for that. Okay, so guys, that's all which I want to tell you guys. No problem, Ravina. So that's what I want to talk to you about before starting the session. That and I think you guys already know me because we have already done the earlier batch. So let's move further and let's see the today's topic. Okay, pair them in the sense two numbers summed and matched to the target value. Yes, correct, Hariharan. That's right. So today's topic, which we are going to cover, these topics are first we will understood searching algorithms, then we will understood different type of searching algorithms there, and then might be we might be solving one question at the end of after understanding all the concepts. Okay, guys. So that's what today's topic is. So first, let's understand what is searching algorithm. Okay, and before moving further or going too deep into these topics, let's try to understand what is algorithms. I know you guys have started like data structure class earlier, so you guys have already has some views or some opinions about the algorithms. Why? What is the term algorithms refer here? Can you guys like tell me about that? What do you guys understood by the algorithms? Okay, so Hariharan is saying complexities. Okay, so yes, I think we can say when people are asking that in interviews, they are going to ask algorithm. So automatically we see that now it is going to be difficult. That round is going to be difficult. So I can relate that complexity there. Okay, by the way, yeah. So Ekta is saying steps in order to perform a task. Okay, in like it could be one part of definition. Systematic steps to get a solution. Okay, Joseph is saying like pseudocode. Okay, step by step solve the questions. We can use algorithms to complete a task. Okay, process of perform any task. Okay, algorithm can be formula slash steps to perform a task. So see, guys, till now, whatever like people are answering here, one word is very common here. That is steps. Do you see? And second thing, which is very common in all the definitions, which is complete a task. Okay. So two things which we are seeing in all the answers, which is steps or completed task. So that's right. So see, guys, we are using algorithms in everywhere. Wherever you see, we always try to find up algorithm for everything. Every scenario, not in only in the computer, in real life also. We always try to create algorithms. I would say that. See, if you want to prepare a tea, so you will follow one algorithm only there. You will first what would be the first step? You will take the pot, put it into the gas stove, right? Put some water, turn on the gas, right? And then put the other material which you want to put. So you guys can take any examples. Every time we try to create algorithms, even like if you want to turn on the fan, there is a procedure for that. Correct? You will go, you will turn on the, you will click on the buttons, then that fan will start everywhere. Like even ironing your clothes. If you are ironing your clothes, you guys are also following algorithms there. Correct? And we always try to make our algorithm better and better. फर्स्ट टाइम चलो अभी कोई नया बंदा है उसको तुम आयरन करने को बोलोगे he can make mistakes, but as an expert, like in an expert who is already doing from iron from very long time, they will tell you no, this is not the proper way. You have to do this thing first, then this. Like if you are ironing any shirt, you know, right, you have to first do sides, then collar and all those things, right? So that's what everywhere, guys, we are following the algorithm. So algorithm is very simple, in very simple terms, well-defined steps to perform a task or to complete a task. Okay, these are well-defined steps. That's why this is very important thing. Well-defined steps. अगर well-defined steps नहीं है, so you guys can do mistakes there. So that's why algorithms always gives us well-defined steps to achieve a task. Correct? So that's what the algorithm is here, guys. Are we good with the algorithms? See, always we get one input and we follow that algorithm and then we get the output. Same in real life also. we want to do iron our clothes. That's the input. After following some algorithms, then at the end we have ironed our clothes. That's the output. Correct? Same goes for tea also. Everywhere we follow the algorithm to achieve some task. So we get some input and we get the final, we follow this algorithm and we get the output. That's what the algorithm means, guys. So now the same algorithms apply in computers also. Correct? Same algorithms applies in computers also. See, in real life, as a human brain, we have a lot of like conscious or unconscious mind. We can easily figure it out, like this is the yellow color or this is this. Like if you want to do iron, we have to like just do one time and we can remember these things. But machines does not do that, right? In machine, we have to tell everything. Correct? That like define this variable there, do the iteration. Correct? Do first do this iteration, then do that, then follow this save these values in there. So that's why in the computer also they have given the name for following all these steps, that wherever we want to achieve something with the computers, we will follow the algorithms. Okay, so right now, as you can understand, we always use algorithms when we want to achieve something. Correct? हम तभी algorithms का use कर रहे हैं जब हम कुछ achieve करना चाहते हैं. Correct? That's right. So that's why what we are going to achieve here, we want to achieve, we want to search something. That's why in this class we are going to talk about searching algorithms. There are sorting algorithms also. ओके, सर्चिंग एल्गोरिथम्स पर्पस इज हम ऐसी एल्गोरिथम चाहते हैं जिससे हम सर्च कर सकें चीजों को, वी कैन फाइंड आउट समथिंग. करेक्ट? एंड द सॉर्टिंग एल्गोरिथम्स we will we want some algorithms which could sort our things, which could sort the things. Correct? So that's what, guys, in the algorithms, as we understood the algorithms, that we use algorithms to achieve some things, and for achieving some things we follow some well defined steps. Okay, now we'll talk about the searching here, guys. What do you mean by searching? अब देखिए, सर्चिंग जब भी कोई कहता है ना, उसमें हमेशा दो चीजें आती हैं. हम ऑलवेज whenever people are talking about searching, they will talk about two things. क्या सर्च करना है और कहाँ सर्च करना है. करेक्ट? लाइक हमारे पेरेंट्स कहते हैं ना कि if you lost your shirt, they will say that वहां जाके सर्च कर लो, वहां रखा होगा. Correct? They say that, like, so that's why always in searching two things always comes: what you want to search and where you want to search. Right? So that's what, guys, in the searching algorithms also we are going to see two things. yes. So in searching always we do two things. Correct? So हम यहाँ पे, हमें यहाँ पर कुछ चीज दी जाएंगी, उसमें से हमें कुछ सर्च करना है. Correct? So that's why, and for searching those things we are going to use the searching algorithms. Okay? अब देखो in JavaScript or I think in any language, हम कहाँ, अब हम पहला क्वेश्चन आंसर करेंगे. देखो, इन सर्चिंग टू थिंग्स आर देयर: वेयर टू सर्च, व्हाट टू सर्च. कहाँ सर्च करना है, क्या सर्च करना है. अब वेयर टू सर्च, फर्स्ट वी विल आंसर द वेयर टू सर्च. अब इन JavaScript if I talk about, so what are the like data type where we can keep multiple things at one place, where we can keep multiple things at one place. Can anyone answer it? Where we can keep multiple data or multiple things at one place. Oh, yes, Vishal has answered array. Nishant has answered object. Array or object. That's totally right. In array or in objects, we can keep multiple things. Right? So this is the place where we are going to search. अब देखो, object में search करना बहुत easy है. In object, because हम ऑब्जेक्ट को इस तरीके डिफाइन करते हैं कि की एंड वैल्यू इज देयर. इन ऑब्जेक्ट वी ऑलवेज फॉलो की एंड वैल्यू. करेक्ट? सो इन ऑब्जेक्ट सर्चिंग इज वेरी इजी. यू जस्ट नीड टू नो द की नेम. In object you can do simply dot, or you can put the curly braces. In the JavaScript classes we have already discussed how to use objects, right? How to use objects, how to find things. In objects it's very easy, but in array it's little bit difficult, because in array we can have multiple things, or those things could be in at any index. that particular data could be at any index. So that's why in array it is going to be very difficult. And while discussing about these algorithms, we are going to take the examples of array only. Okay, and these all algorithms are written with the arrays only, in like with the taking example of arrays only, because in array we are going to keep the multiple data. Ab dekho, in array we can keep multiple data. It means we can keep strings also, we can keep binary also, integers also, multiple data types we can keep in array. But while working on these algorithms, in searching algorithms, we are only going to talk about the integers. We will keep the integers. So why we are doing that? So we can easily understand these searching algorithms concepts. Okay, that's why we are going to take the array, and in array we are going to take the integers. So so why we are doing that? So we can easily understand these searching algorithms. Okay, are we good that? So now, while talking about the searchings, I told you we need two things: where to search, what to search. For where to search, we have decided we are going to use array, and what to search, उसके लिए हमने decide किया we are going to take the integers. हम integer search करेंगे उस array में. Okay, guys. So that's what the searching all about. That's what we understood about the searching. That's all the base I have created till now. Okay. So we started with understanding the use cases of these algorithms. Then we talked about the algorithms, and then we talked about the searching. Little bit about the searching. Are we good till now? Should we move ahead? Okay. Great. Okay, okay, so now let's talk about the searching algorithms, guys. So there are three type of searching algorithms which they have provided till now. One is the linear search, second one is the binary search, and third one is the ternary search. अब देख रहे हो इनका नाम ना लिटिल मैथमेटिकल नहीं लग रहा है तुमको? लीनियर, बाइनरी एंड टर्नरी, right? So guys, these algorithms are little bit, they relate with mathematics also. They once we talk about these algorithms, they similar thing happen in mathematics also. So that, but we will not go into that part, because we are the computer engineering students, and we are going to talk, we are only going to learn that much stuff which is important for solving our problems, because we want to crack our interviews. Okay, so that's what we will, but yeah, we will see little bit things in the mathematicals also about these linear, binary and ternary. But the most used, guys, I'm telling, most used searching algorithm which I have seen, like while I was interviewing for PayPal also, the most used algorithm which the most used searching algorithm they have asked, that's the binary search, guys. That is the binary search. They have asked lot of places, and lot of questions could be solved by the binary search. Linear search, it's very, like, first I'm telling you the use cases of them, then we'll discuss about the searching algorithm. So see, linear search is very straightforward. Like everyone, whoever is doing, I think you guys have already done the linear search. जब भी तुम्हें कुछ एरे में फाइंड करना है, तुम linear search ही करते हो. You guys are already doing the linear search. There is nothing new in the linear search. But yeah, binary and ternary, see, you guys know, till now I have not heard about ternary till now. I'm just like, while reading the slides, I was first time reading about the ternary search, and I've seen the real examples why ternary search comes into the picture. I got very good example actually why the ternary search sometimes could be useful, where binary search could fail. So there are some examples where binary search could fail. But guys, lot of problems could be solved with the binary search. Lot of problems. Okay, so that's why. So see, binary search, हमें सिर्फ concept समझना है, हमें implementation नहीं समझना है. We will understood first the concept कि binary search कहता क्या है, करता क्या है. Okay, then we will understood the implementation of them. The how can we implement the binary search. Same goes for ternary search also. First we will understood what is the purpose which ternary search is solving. Then we will understood the implementation. Okay, guys. So that's how we are going to proceed. So see, linear search, we are already doing that. हम जब भी कुछ भी find out करना होता है हमें array में, हम linear search ही करते हैं. तुम ऐसा समझो. Whenever people are talk about linear search, like whenever you are doing anything, like whenever you are searching, filtering anything in the array, you are already doing the linear search there. Okay, so but that so that you are already doing, but binary search and ternary search is a little bit different in that. Okay, so let's see some of the examples. Like let's try to understand linear search and binary search with little bit real life example. Okay. In meanwhile, let's see. Anyone has answer? Anyone has a question? Ashwin is saying yes, sir. We check every element. Yes, in linear element we check every element. That's right. Deepak is saying divide the array into three. Yes, in the ternary we do that. Divide. See, ternary and binary, like just for remembering things, guys. In binary we divide the array in two parts. In ternary we divide the array into three parts. That's why binary means two, ternary means three. Linear कोई divide नहीं करना है, सीधे चलना है उस पे. Okay. So, but yeah, this is just for our understanding. Okay. Ankit is saying, whenever I search, I always try by linear search and then go for other. Oh, yes, actually, linear search is also known as brute force. Brute force means you are just trying from the start, and then you are going like then you are trying to improve your solution. Then you go for others like binary search or might be ternary search. Yeah, then you go that way. Okay, guys. So let's see. Okay, let's see very easy example to understand linear search and binary search. A ternary search, I didn't find any good example in the real life, but I'm trying to understand, like still trying to figure it out any real life example. But yeah, in the array, I have very good example where we can understand the ternary. Okay, but yeah, let's understand the linear search and binary search. So let's take a dictionary example, guys. It's very nice example to understand linear search and binary search. Okay, so or dictionary or yeah, let's take the dictionary. So see, in a dictionary, if you want to find out sun, spelling of sun, so what you guys will do? For the you will open your dictionary and then you will see the first letter which is coming here, which is coming into that page. If that first letter is P, like I'm just considering, just guessing, if the first letter is P, what you will do? What is the next thing you do? You go ahead, correct? You go ahead. You just तुमने और पेज पलटे, करेक्ट, एंड देन यू विल सी जैसे ही एस आया अब तुम सेकंड लेटर देखोगे, करेक्ट, अब तुम सेकंड लेटर देखोगे. Now you will see the second letter, correct, and then you will once you will go into that page, once you find out the second letter, now you go for the third letter, correct. So guys, this way I think we can say that we are right now following the binary search only. अब देखो लीनियर सर्च होता है तो क्या करते हैं. नाउ इन द केस ऑफ लीनियर सर्च, you know what you will guys do? You will start from first page. First you will open the first page, then you will open the second page, then third, then fourth, then fifth, then sixth, seventh, and then you will go like that. This is the linear approach. See, these are approaches. Linear search and binary search, these are approaches to solve a problem. See, algorithms are, what is the algorithms? Algorithms provide you the ways to solve a problem. करेक्ट. अब तुम्हारे सामने प्रॉब्लम आई कि यू हैव टू फाइंड आउट दिस वर्ड लाइक शन इन द डिक्शनरी. अब तुमने सबसे पहले लीनियर अप्रोच अपनाई. फर्स्ट यू फॉलोड द लीनियर अप्रोच. सो अकॉर्डिंग टू लीनियर अप्रोच व्हाट यू डिड, यू स्टार्टेड फ्रॉम फर्स्ट पेज, then second, third phase, then third, fourth, fifth, and then go on. This is the linear approach. And now you can automatically understand the problems here. सबसे पहले बहुत सारा टाइम लगेगा because dictionary is not very small data set. Dictionary is too big. They have letters from A to Z, and in the A only, I think there could be 35 pages. Correct? So with a linear approach, it's always take lot of time. Correct? But the binary approach, what you did, you started in somewhere middle. In somewhere you started with in the middle, and then you tried, then you compared that your letter which you are searching, is it greater or smaller. अब तुमने देखा कि P और S में तुमने देखा कौन पहले आता है. तुमने देखा P comes first. Now it means you have to go ahead, you have to go on the right side, correct. That because P comes before then S, so that's why what you will do, now you will go on the right side. That's what the binary approach is, guys. In any of the data set, first you will find out the middle place, Then in middle place, once you reach the middle place, now you will compare where to go from your target. जो भी तुम्हें target दिया जाएगा उससे you will compare it. Now if your target is less than, then you will go for the left side. If your target is greater than, you will go on the right side. Okay. So guys, this is one example. Up the second example, same we will go with the books. So like if you remember, like in the night you were reading a book, right? I got this example while I was searching out the examples. So in the night you were reading a book. Okay, in that book, like once you were going to keep the book and going for sleep, you remember the page number, and that page number what was 123, or like yeah, 123. Next day when you started reading the book, what you will do? You will again follow the same step. You will again follow the binary approach there. You will first open the book in the middle, then you will check the page number. If it is 79, it means it's lesser, and your page number was 123. Now what you will do? You will go on to right side, correct? And then slowly you will reach to your 123 page number. Okay, guys, this is what the binary approach is. Okay, so what is binary approach? See, first understand linear approach. Linear approach, you will start from the starting page, and then one by one, you will open all the pages, and then you will go for the 123. This is a linear approach, correct? But in the binary approach, you will first find out the middle place. Okay, once you find out the middle place, now you will compare it, and then compare it with your target, and then based on if it is lesser than, then you will go on the left side. If it is a bigger, then you will go on the right side. Okay, so that's what the guys, again, if anyone has any doubt on the approach between the linear and binary, they can ask me in the chat. Let me meanwhile look for the questions. So linear search is good for small data. Yes, for small data, we can say that linear search could give us better or faster time complexity. Yes, it could give us better results or faster result in a small data, but in the bigger, it will definitely create a lot of problems. Is linear search is also known as a two-pointer approach? Two-pointer approach? No. That's not a linear approach, I would say. In two-pointer approach, you're also what we say, reducing your data size, reducing your data set in two-pointer approach. But yeah, linear approach, only one side. It goes from the one side. No, it's sequential approach, Nishant. Yes, it's a sequential approach. Yes, the linear approach is also known as sequential approach. That's right. No, Nishant, using linear, we can also do two-pointer. If data is sorted, then must go with the binary search. That's right. That's right, Ankit. I think this is the next thing which we are going to discuss about the binary search. We'll talk about that. Okay. So are we understood the linear approach and binary approach? First you guys tell me about that. Are we good with understanding the approaches first? Are we understood how the linear approach works and how the binary approach works? Are we good with that? Okay. Great. Is it necessary to sort? Is it necessary to sort for linear search? No, Niranjan. For linear search could work on sorted and unsorted anyway. Because see, linear search इन चीजों पे डिपेंड ही नहीं करती है. Linear search का सिंपल फंडा है, हमें शुरुआत से स्टार्ट करना है. Linear search has simple funda. It has to start from starting, even if you have the sorted data or unsorted data. It doesn't matter there in the case of linear search. Okay. Okay. So now, before going further, guys, let's understand sorted and unsorted also. What does it mean by sorted and unsorted? Okay. So see, let me also share the slide so we can understand the sorted and unsorted also. So see guys, sorted could have two things. हम sorted को two ways represent कर सकते हैं. Okay. So let's see. In sorted, this could be two ways. Okay. Sorted can go on two ways. One is the increasing, and second could be decreasing. Okay, in increasing, whatever data set we are going to take, we are going to talk about array right now, right? So this will be increasing when we are going into an increasing way. Or sorted, guys, sorted means, if somebody is not aware of the sorted means, you remember, like, in your class, when somebody is giving you a scorecard, so they sort it. Like, they say that this person is the, this person rank is first, this person rank is second, this person rank is third, this person rank is fourth. Correct? In that way, they in that way they order you. Correct? In that way they will stand you in the line. So that's what the sorted means. Sorted means, like, in one order they will stand you. Yeah, they will keep you in one order, and that order could be in the increasing order or could be in the decreasing order. अब देखो, इससे हमें हेल्प क्या मिलती है? Why we do the sorting? In the sorting, whenever we are doing the sorting, like, we can easily find out which is the biggest, which is the lowest. We can easily find out which is the biggest number or which is the lowest. Like, in the same way, in the score, in the in the ranking in schools, we can easily find out who is first in class, who is last in class. Correct? So that's why, guys, sorting we use in lot of places. Like, in the dictionary is also sorted. I think in the increasing order. Lot of places we do the sorting, क्योंकि sorting से ना हम easily चीजों को find out कर सकते हैं. जो रिट्रीवल होता है ना, किसी चीजों का रिट्रीव करना, वो हम इजीली कर सकते हैं विद द हेल्प ऑफ सॉर्टेड. करेक्ट? इवन इफ यू आर सॉर्टिंग इन इंक्रीजिंग ऑर्डर और इन द डिक्रीजिंग ऑर्डर. So that's the meaning of sorting only. So see, right now it is increasing. Let's create a decreasing also. Decreasing would be opposite of earlier one. 7, 6, 5, 4, 2, 1. Correct? So this is the decreasing. It's not like that. Like, let's see, you can see I intentionally missed 3 there in both of the places. Correct? Intentionally. So you guys should not think like, if we are talking about the sorted, it means like number should, all the number, it should be sequential also. Like, 1, 2, then third should come, then 4 should come, then 5, fifth should. It's nothing related to that. Sorting means everything should be in the one order. Even if number is not, like, if the next number is not coming, still that is fine. But sorting means everything, like, the next number should not be lesser than, like, you can see 1 is smaller, second, so 2 is greater than 1, 4 is greater than 2, 5 is greater than 4, or 6 is greater than everything from the left side, 7 is greater than everything from the left side. Same goes for decreasing also. 7 is greater than everything from the right side, 6 is greater than everything from the right side. That's what the sorting means. Okay? And unsorting, जो भी sorting नहीं है वो unsorting होता है. Unsorted, very simple definition. Whatever data set is not sorted, known as unsorted. अब देखो unsorted array क्या होगा? Same array we can take for the unsorted also. Unsorted. And that could be increasing, decreasing, nothing matter. It could be 1, 3, 7, 8, 4, 2, 0. This is unsorted. हमें कहीं भी कुछ like एक तरीके का sequence, we cannot see any sequence or any order there. Correct? Like, number is increasing, number is decreasing, then again increasing, decreasing. There is not any common pattern. But in the increasing and decreasing, you can see one common pattern. In increasing, it is just continuously it's increasing. In decreasing, it is continuously decreasing. So binary search has one condition they have given, that always binary search will work with sorted scenarios. Always binary search algorithm will work with sorted scenarios. Why? Because you know the binary search approach. Because you know the binary search approach. What is that approach? First, find out the middle element. So now you can see this is the 5 is the middle element. Then if your target is lesser than 5, go for left side. And if your target is greater than 5, go for right side. This is the right side, this is the left side. Same goes in the decreasing order also. find out the middle element. After that, if your target is lesser than that, go for right side. If your target is greater than that, go for left side. So guys, that's why I told you that first understood the approach what binary search has, and then understood the sorted. Why we need the sorted there? Because sorted only helps to binary to achieve their results. Because if your array is not sorted, you cannot apply binary search there, because binary search has given you the steps which are saying, see, binary search algorithm always provide you step. Everything is linked, guys. Binary search is an algorithm always provide you steps. So what are the steps which binary search provided? It says first find out the middle element, then compare that middle element with your target which you are looking for. Then if it is the lesser side, go for left in the increasing order scenario. If it is a greater, go for right. If it is a decreasing, opposite. If it is a lesser, go for right side. If it is a greater, go for left side. That you can understand. Like, I'm just repeating same things again and again. You guys might be confused. So do not go with me. Go with these words. Go with the example in the increasing and decreasing order. Okay. Now, are we good with understanding the sorted part, increasing and decreasing thing? So Ankit was saying something. Wait. Yeah. With the help previous, we can find the next in sorted. With the help previous, we can find the next. Yes, actually, yes, that's right. Because they are following one ordering. So if something is already covered, you know that the next element would be greater. ये by default हो गया है. Increasing sorted order में अगर तुमको data set मिला है, if you got some data set in increasing sorted order, it's already default that next element, whatever you are going to get, it's going to be greater than the left side. So this is automatically defined there. Every algo have their own steps to order to solve a specific problem. Yes, that's why we create the different algos. Okay, guys. So we have understood the sorted and unsorted means. Okay, let me check if I am missing anything from my. I have written some points. So let me just check 1 minute. So yeah, I think we are good. So we can now start understanding the understanding these algorithms with one array. Till now, we understood the linear and binary search with the real life examples. Like we have taken the binaries there, right? Like the dictionary there, or we have taken the books, right? We are trying to understand with that. Now let's take one array, because that's what we are going to search in the computer science. That's what our machine is going to do. Why we are writing these algorithms? To make our machine efficient, to search some things. Correct? That's why we are writing these algorithms. That's why we are writing these algorithms. ये algorithm हम real life में नहीं implement कर रहे हैं. These algorithms and these searching algorithms we are writing for our machines, so they can easily find out the things. Okay. So let's now take in any any array examples, and first let's go through the linear approach, and then we will look for the binary approach. Okay, guys. So let's see, they have given also one example. So we'll take that one. Okay, so they have given this one. So I will take the same data, and then we will talk about it. Okay. So guys, nothing to fear about. And if something you are not able to understand, try to write in the chat, and let's talk about it. See, whenever we find any difficult topic, it's good when you talk. When you will talk, you will try to understand more things there. Okay, so that's what. Let's start understanding this linear search first. Then we will go for the binary search. And I want you guys also to be participate here in the chat. Then whatever we're talking, you will understand. Okay. So let's take the same examples and let's start with understanding the linear search and that part. So let me take the example here. Okay. Let's take this green color and let's take one first array. This is our array. And because why I'm taking the same example, so later in later class, you guys want to go for slides, you guys can relate whatever we are talking about here. Okay. So 1 minute. Let me take the same number 4, 5, 3, 2, 6, 9. Okay. So first was the 4, 5, then 6, then 2, then 3, then 9. Okay. And let's see what they are looking for. And they are looking for, searching. I told you two things, right? In searching. First thing, where to search. Second thing, what to search. Correct? So now we got where to search. हमें इस एरे में सर्च करना है. करेक्ट. अब नेक्स्ट व्हाट टू सर्च, वो हमारा टारगेट होगा. मैं टारगेट यहां लिख रहा हूं, विच इज आवर टारगेट. एंड नाउ द टारगेट इज 3. हमें फाइंड आउट करना है इस एरे में 3 है या नहीं, 3 एग्जिस्ट करता है या नहीं. ओके, दैट इज द थिंग विच वी नीड टू डू. और दैट we are very brilliant person. We can easily tell in this array that at the like 0 1 4th index 3 is there, but our computer is not that much intelligent. So that's why we need to find out some algorithms. We have to find out some algorithms so our computer can also do the same thing. That's why we are writing the algorithms. I am repeating these things again and again so you guys can explain to others also why computers are important, why algorithms are important. Okay, that's why I'm repeating these things again and again. Okay, so let's first follow the linear approach. Okay guys, so we'll follow the linear approach. Okay, so see, it's an array, so always array has indexes. Okay, so this is a 0 index, this is a 1 index, this is a second index, this is third index, this is the fourth index, this is the 5 index. Are we clear about that? Everyone knows that, right? That the array has the indexes, and always we try to start the array index with 0. Correct? Now we know that. Correct? Now according to linear approach, as I told in the book, as I told, in the linear approach, we always start from the first page. Correct? We always start from the first page. In the similar way, here we will also start from the first index. So सबसे पहला क्या होगा? We will go for 0th index. So हम समझो एक loop चला रहे हैं, ठीक? So the first loop. So this will be first iteration. In the first iteration, we will go for 0th index, and at the 0th index we will get the 4. Correct? I will write 0th index. अब हमें 4 मिल गया 0th index पे. हमने उस पेज को खोला. You can see the page. You can relate the same example with the page also. In the page you can see the first page number is there. In the similar way in array, first element is the 4th at the 0th index. Now we are comparing it with the target. Is 4 equal to 3? Is 4 equal to 3? We'll say no. Correct? We'll say no. Now we need to go. Now this element is not same. Our target is not matched. Now we need to go for second iteration or second element. So now we'll go for second iteration. At the second iteration, what we got? 5. Correct? We got the 5, which is our second element. We'll do the similar thing. We'll compare it. Is 5 equal to 3? We'll again say no. Okay? We'll again say no. Okay, that's okay. We'll go for third iteration. Now we'll go for third iteration. At third iteration, we got 6. Correct? Is 6 equal to 3? We'll again say no. This is linear approach. Now we will go for fourth iteration. और ये हम नहीं कर रहे हैं, ये कंप्यूटर कर रहा है. This is the computer which is doing. We know, in our eyes, we know that 3 is at the 4th index. But no, computer is not that much brilliant. Computer has to go one by one. So that's why all these things computer is doing. We are not doing. Okay. Now let's see the 4th index. In the 4th index, we can see element is 2. Correct? Sorry, 4th iteration. See, guys, difference between iteration and index. You see, iteration is like we are taking iteration from first 1. That's why iteration and index are not matching. Are we clear with that? Why iteration and index are not matching? Because index are starting with 0 and iteration is starting with 1. That's why. If no, do not be confused with these things. Okay. So you can see at the 4th iteration and at the I think I missed that somewhere. Yeah, I think this is. That's why. Sorry guys, I missed it. I written the second iteration, second index. Sorry for that. First index and second, because I am writing here indexes. Let me take the eraser. Otherwise, it could create little bit confusion for some people. Yeah, I missed it. Sorry, guys. Yeah. So yeah, this was the first index. I missed it. Yeah, and this is the second index. Correct. Now we are at the third index. I'm writing it here. Third index. Okay. Now we are good, right? Fourth iteration, third index. Third iteration, second index. Second iteration, first index. First iteration, zeroth index. Good, right? Now we'll compare the fourth iteration. So fourth iteration, what we got? 2 in fourth index, and at the third index we got 2. Is 2 equal to 3? Our target is 3. We'll again say no. Go further. Now we'll go for fifth iteration and fourth index, which is 3. Now, is 3 equal to 3? Yes, it is. 3 is equal. Now what we will say? Yes, we found our element. Now we will simply return from here. We will return from here our computer system. We not. Our computer system will return from here and will provide us the index. Will provide the index, and that index would be 4. Index. I'm writing index 4. Okay, guys. That is linear approach. Is any doubt here? Any question here to understanding the linear approach here, guys? Clear? Now we will look for the binary approach, guys. Okay. Okay. So let's see. So now we are good with the linear approach. Every time. अब देखो linear approach में हमें sorted or unsorted से मतलब नहीं है. It doesn't matter. It is sorted or unsorted. It doesn't matter. Because linear approach का simple फंडा है. हमें सबको एक एक करके चेक करना है. Linear approach has very similar simple funda. I need to search everything. So if you are sorted, unsorted, doesn't matter. I'm not going to use you. So that's why you can. Okay, anyone can tell me. Can anyone tell me that this array is sorted or unsorted? Please tell me. This array is unsorted or unsorted? Yes, it is unsorted. Why? Why? Because it is not following any trend. It's not increasing, not decreasing. Sorted always follow 2 trends, which is increasing or decreasing. You can see this is like 4, 5, 6, 2, 3. Like if I want to draw a graph for this, let me draw a graph also for this, for the same array very quickly. 4, 5, 6, 2, 3, 9. You guys in 10, 12, might be in 10th, right? You guys have read about the coordinates, right? I remember in the coordinates we have I think in from class 8th or 9th, I think coordinates has started, right? So this will be x-axis, this will be y-axis, right? I think Hariharan is saying from 6th. Might be, I didn't remember. Yeah, in graph actually. So like if you are talking in the x-axis, if these are the x credentials, so this would be something like this. See, first it is increasing. So like it will start from the 4. So we can say this is 4, right? This is 3. This is 2. Something like that. Randomly doing, guys. 5. This is 6. Somewhere 9. Like, so it will start from 4. Then it will go for 5. Then it will go for 6. Till now it is increasing. Then again, it is coming back to 2. Then 3. Then again going to 9. Is it following a single trend? No, right? It is just random trend it is following. Up increasing, decreasing. It's not it's not following any sorting order. So that's why this is unsorted. Okay, guys? Yeah, it's not linear actually. If linear will be like in the same way. Linear would be something like this, right? Same goes. I'm not that much good in that, but what I'm thinking it could be the linear, right? Or if you're talking about this linear, Joseph, yeah, just like cryptograph. Yeah, crypto or stock graph. If you guys are investing money in stocks, so you guys will see that always stock goes up, down, up, down, up, down. So that's what in stock market. Yeah, linear search is like government bus. We need to go every stop to reach destination. Very nice example, Sanwas. Yes, it's a government bus. Absolutely, like very nice example. It has to. Like doesn't matter. It has to stop it will stop in every bus stop. That's totally right. Nice imagination. I think yeah, that's what actually that's how we make these complicated subject easy. That's how we make it. Okay, guys. So now, yes, similar passenger train. Yeah, same example. Okay, guys. So now we will move into the binary search. Okay, which would be see the condition of binary search is it should be sorted array. The condition is sorted array. क्यों? क्योंकि binary approach always because we need to follow the binary approach. Our binary approach will only work in the sorted array. Okay, so let's first create one sorted array. Let's take a very simple example. I am not going to back to the slides. Okay, let's see if we'll take the slide example. You guys can later like understand that better. So let's take the binary search quickly. Yeah, they have taken this example 1 2 5 7 13 15 16 18 24 28 29. I think yeah, they have taken, that's fine. I will take a smaller one. Okay, guys, I will take the smaller one. They have taken big example, right? So let's see again, searching algorithm, binary search. We are going to talk about the binary search. So two things always needed: where to search, what to search. Where to search would be an array. An array this time is going to be sorted. So I'm just simply taking 1 like 3 4 5 7 9. Okay, you can see this is following one trend which is increasing, correct? Now we can check for what to search, or like what target we, let me take the target here. The second thing is what to search, correct? So our target is like we can search for 5 or 7. Yeah, let's take the 7, which will increase our iteration, correct? Let's take the 7. We're going to search the 7 here. Okay, so this is the example which we are going to take. So see, first condition of binary search, it should be sorted. So our array is sorted, and this sorted is increasing order, not in decreasing order. Okay, so now in increasing order, the first thing for us is find out the middle element. Okay, find out the middle element. So right now it's like 6 elements are there. So I think it's an even number, right? So 3 is there, 3 is this side. So we cannot find any middle element here. So we can randomly take any of element from here, correct? So like any element, take any middle element. Okay, so let's see. I am taking this one, fourth one. Okay, I just taken any element from the middle. This is a 4 I've taken. Okay, so like in the first iteration, like again iteration 1. This time we are not going with the indexes. You can write the indexes also, 2 3 4 5. But yeah, we are just simply talking about the approach till now. ठीक है, तो सबसे पहले हमने क्या किया, मिडिल एलिमेंट निकाला. ओके, सबसे पहले मिडिल एलिमेंट. Yeah Nilanjan, we will go with the like that understanding, but let's find out the middle first. So randomly I'm deciding it's the 4 is the middle element, but you know the rule is to find out the middle, take the left index or take the right index. Take the left index and take the right index and then divide by 2. So see, you will still find out the 2 only. Let me tell you, left index in starting, left index plus right index divide by 2. If you will do this, you see 0 plus 5 divide by 2, which would be 2.5, correct? We will take the floor value like the first data. So it will again give you 2. See, there is multiple ways to find out. Some people find out like this. Some people do this, right index minus left index divide by 2. They will also find the same result. 5 minus 0 divided by 2, 2.5. So इसलिए हम कोई भी तरीका फॉलो कर सकते हैं, बट हमें सबसे पहले what is the first thing which we need to do? That is find out the middle element. Okay, find out the middle element. So जैसे ही हमने find out कर लिया middle element, which is 4, or index is 2. Index is 2. You can see at index 2, our middle element is 4. Now what is the next? We need to compare it. Now we need to compare it. Is this middle element, which is 4, middle element 4 is equal to our target, which is 7? No, right? No, right? This is the result. No. Correct. So now what we will do? Now what we need to do? Now we understood, because this array is sorted. Now we understood that our first thing we understood this, that the middle element is not equal to target. अब हमें क्या करना है? अब हमें एक तरफ चलना है. अब हमें किस तरफ चलना है? Now we need to go one side. And now what will be that side? Now we need to compare it. Is the target element is greater than my middle element or lesser than? Now there will be two conditions, guys. Two conditions. Is the middle element 4 is greater than 7, or is middle element lesser than 7? First we'll compare that middle element is equal to target or not. Guys, you can see three conditions are there after finding out the middle element. You see, first you find out the middle element. Once you find out the middle element, there are three conditions. First condition, is middle element equal to target? अगर हमारा वही वाला नंबर है जो हम फाइंड आउट कर रहे हैं, हम यही स्टॉप कर जाएंगे, हमें जाना ही नहीं आगे. विल नॉट गो फर्दर बिकॉज वी फाइंड इट आउट द एलिमेंट. वी विल सिंपली रिटर्न द इंडेक्स. But if this is not the case, then we need to check two more conditions. And now these two more conditions are, is the middle element, which is the 4, is the greater than our target or lesser than target? If it is the greater than target, if my middle element is greater than target, then we will go for the left side. We'll go for the left side because our middle element is greater. It means we are looking for something less. Something like if we are looking for 3, अगर हम 3 को देख रहे होते तो हम फिर लेफ्ट की तरफ जाते, बट यहां पर ऐसा नहीं है. अब देखो ये वाली कंडीशन हमारी रॉन्ग हो जाएगी. नो, 4 is not greater than 7. So that's why this is not the true condition. But this is true because our target is greater than the middle element. So this is the true condition. Now we need to go for the right side. Now we need to go for the right side. Now we need to go for the right side. And now you know what we do? We make our middle. अब हमारा जो मिडल है उसको हम लेफ्ट बना देंगे. हमारा जो लेफ्ट हो जाएगा ना, अब वो मिडल +1 हो जाएगा और मिड हो जाएगा, और राइट अभी भी सेम रहेगा. राइट अभी भी सेम ही रहेगा जो 5 है. अब हम क्या देखो हम बता रहे हैं अभी. डू नॉट गेट कंफ्यूज गाइस. Do not. I know that this could be confusing. That's why I'm going to repeat it again. So once you find it out, guys, once you find it out that this second element is not equal to my target, now the next step is go to right side. क्यों हम right side जा रहे हैं? क्योंकि हमने पता लगाया, because we have find it out that our middle element is lesser than target. अब lesser than target है और हमने increasing sorted, हमने जो एरे लिया है वो सॉर्टेड इंक्रीजिंग है. इसका मतलब हमारा जो अब एलिमेंट है वो राइट साइड ही होगा. एम आई राइट? फर्स्ट टेल मी दिस थिंग. सी, वंस यू अंडरस्टूड दिस थिंग, व्हिच साइड आई हैव टू गो, देन अदर थिंग्स आर वेरी इजी. सो फर्स्ट दैट्स व्हाई ट्राई टू अंडरस्टैंड व्हिच साइड वी हैव टू गो. ओके, सो नाउ सी इन दिस सिनेरियो, इन दिस एग्जांपल, आर 7 इज ग्रेटर देन 4. आर 7 is greater than middle element. So that's why we have to go for right side. Correct? No need to go for left side. अब हमें लेफ्ट साइड के कोई भी एलिमेंट को टच नहीं करना है. We do not need to touch any element from the left side. We have to go to directly now on the right side. हम अब क्या करते हैं इसके लिए? टेक्निकली क्या करते हैं? हम अब अपने मिडिल को ना लेफ्ट बना देते हैं. अब हम कहते हैं हमारा लेफ्ट यहां से स्टार्ट हो रहा है. We will say that our left is starting from here. Now this will be the left, this will be the right. Again find out the middle, and now the middle would be 7. Now the middle would be 7, and then we will say that yeah, our element is found there. So you see now what? See technically how, like we know that with our human eyes we know that we need to go now for the right side. अब हमें क्या करना है? 5 और 9 की भी सर्च करना है. But computerly, how we tell to computer, what we do, we change our left. Till now our left was 0, but now we will say that we start our left from mid plus 1. मिड प्लस वन, क्योंकि मिड तक हमने चेक कर लिया है, हमने मिड तक चेक कर लिया है, वी हैव नॉट फाउंड इट, और हमें मिड से पहले चेक नहीं करना है. क्यों? क्योंकि हमारा टारगेट बड़ा है मिड से, तो हमें अब यहां तक कोई लेना देना ही नहीं है. वी डू नॉट नीड टू, दीज थ्री नंबर डजंट मैटर नाउ. So that's why now our left will start from here, mid plus 1. Okay, so that's what, guys, I think I went little bit technical also here with the, because I do not want to go in this technical step. I just want to simply tell you about the approach, how the approach is working. But I thought to share these little things also. I'm sure this could be a little bit confusing for some people, but yeah, you guys can tell me where you guys stuck here. I know like this could be for some people, it could be a little bit confusing. Okay. Yeah, so Nilanjan is saying why we take left is equal to mid plus 1. Sure, Nilanjan. See, I think this has become little bit like too much thing I'm writing in the same slide. So let me go to the next slide, then we can explain there. Yeah, let's take the same example there. So 1, 3, 4, 5, 7 and 9, and our target was 7. Correct? This was our target. So क्या हुआ निरंजन, हमने पहले mid find out किया. Okay, first we find out the mid, which was 2. This was this 4, right? If index was 0, 1, 2, 3, 4, 5. We find out the second index. Correct? This was the mid element. अब हमने क्या किया, हमने चेक किया कि this middle element is not equal to a target. Okay? और second thing हमने क्या find out करी कि हमारा जो mid element है ये छोटा है. It is lesser than our target. It means we have to go to right side. Correct? It means we have to go to right side. So अब हमने क्या किया, हमने अपने लेफ्ट को, अभी तक हमारा लेफ्ट यहां पर था, यहां पे लेफ्ट था और ये राइट था हमारा. करेक्ट? ये लेफ्ट था 0 पे और राइट था हमारा 5 पे. राइट? That was the scenario. I think I missed telling it earlier. So guys, 0 would be our left and 5 will be our right. That's how we'll start. These indexes will be our left and right. So till now, guys, left was as 0, but now we have identified that our target is greater than mid element. We do not need to touch these elements now. We do not need to touch these elements now. So that's why now we are bringing our left to here, to the next element of mid, to the next element of mid. So that's why we are writing left is equal to mid plus 1. और mid क्या था? 2. Mid, no guys, do not confuse that mid is 4. Mid is mid is 2. At the second index, what is the element? That element is 4. Okay, so mid is 2. 2 plus 1 is equal to 3. अब left होगा हमारे third index पे. Yes, Joseph has told correctly. Guys, left, always left, mid, right. These all three things are indexes. Always remember. I think I should tell this thing earlier, but now I'm telling this. Left, mid, right. These all three things are indexes, not the element. See, difference between index and element. Difference between index and element. Index is 0. Element is 1. Index is 1. Element is 3. Index is 2. Element is 4. Index is 3. Element is 5. Index is 4. Element is 7. Index is 5. Element is 9. This is the difference, guys. Always remember. और हम जब भी, whenever we are going to talk about left, mid and right, we are going to talk about indexes. This part. Are we good with that, guys? Now is it clear, Nilanjan, to you? Our tar is 5. Our target is 7. Navneet, our target was 7. You can see target is mentioned here. Let me take the another color to point it out. This was our target. Okay. So Nana is saying, okay, if our target is 5, Yeah, so still we will go into the still we will go into this side. Still we will go into this side only. Navneet, okay, Navneet is saying if our target is 5, what will happen? Still we will go into the right side. और फिर से हम लेफ्ट मिड को निकालते, मिड होता हमारा ये 4, हम सेकेंड इंडेक्स में मिड हमारा होता 4, और फिर से हम चेक करते कि हमारा जो मिड एलिमेंट है वो छोटा है या बड़ा है. हमें पता चलता है कि छोटा है, तो अब हम लेफ्ट साइड जाते. करेक्ट, अब हम लेफ्ट साइड जाते तो हम फिर 5 के पास आ जाते. ऐसा करते हैं. ओके, we will see these examples. We'll see these examples. Okay, so Nana is saying, sir, I'm not getting why mid plus 1. Please once again. Oh, okay, okay. So the reason for mid plus 1 is just because of हमें ये सारे एलिमेंट नहीं कवर करनी है. नैना, we do not need to now cover. See, हमने ये वाला एलिमेंट को हमने चेक कर लिया है. Did you understood that this index we have already checked? करेक्ट नैना, दिस इंडेक्स वी हैव चेक. अब हमें क्या करना है, नेक्स्ट एलिमेंट हम उसके आगे ही चेक करेंगे ना. हमने आइडेंटिफाई कर लिया, वी हैव आइडेंटिफाइड दैट वी नीड टू मूव राइट साइड. वी हैव आइडेंटिफाइड वी नीड टू मूव राइट साइड. करेक्ट, सो दैट्स व्हाई आई हैव एंड till this index we have already checked this index. So that's why we are doing left is equal to mid plus 1. So that's why we will start from here. We can start from here also. That's not a fine, that's not a problem, but I think we have already covered this element. That's why we are moving further. Otherwise one more loop will be needed there to just figure out the 4. Correct, one more loop will be needed if we are if we are not doing mid plus 1. This element could also be checked later, but we have already compared this element, so why to compare it again? We have already compared that 4 is not our target. The element 4 is not our target. That's why we have to move further. That's the reason we are going to look for. That's why we are doing the mid plus 1. In the right scenario, in the right scenario we simply do mid minus 1. हमें क्योंकि मिड को राइट को कम करना है और लेफ्ट वाले में मिड को हमें +1 करना होता है, क्योंकि हम लेफ्ट को आगे बढ़ा रहे हैं. लेफ्ट हमेशा इस तरफ बढ़ रहा है, इसलिए वो 0 से मिड +1 होगा, और राइट हमेशा लेफ्ट साइड जा रहा है, उसको मिड -1 करना पड़ता है. So we'll see these examples. Okay, so are we good guys now with these examples? The linear and the great guys. I'm also thinking to tell you about the ternary also. Okay, let's take one more slide and let's just approach. I'm trying to tell you approach. Okay, where binary will fail. I have taken one example. I've seen one example where binary will be failed. So see, let's take one array. 1, 2, 3, 4, 5, 5, 6, 6, 5, 5, 4, 4, 3, 2, 1. Okay, is ternary important? I have not seen anywhere seriously any example of ternary, but yes, I have seen these type of problems could be come into the ternary also. So yes, this is not sorted. That's totally right, Arad. But this is following one trend. If you will see that this is following one trend, it is increasing then decreasing, increasing and decreasing. Okay. See, this is also one type of trend, and this type of trend is called this type of trend is go like this. You, like the pahads, the hills, that shape. In these type of problems, we have seen that ternary helps us. In these type of problems, we see that ternary helps us. Okay, and in like mathematicals, I think we say these terms, these shape, a biotomy, something like that. I have the name there in the slides. We'll see that. Okay, so these type of problems, guys, in these type of approaches, we cannot go with the one mid. We cannot go with the one mid here. Let me first erase this one. See what is the problem? Says, can you guys see if we apply the binary here, what could be the problem here? Anyone? If we apply binary search algorithm here, what problem do you guys see? Anyone? Unsorted, okay. Yeah, I know that unsorted, it's not sorted, it's not, but you can see in till some space, it is sorted, right? Till here, if I talk about, yeah, till here, it is sorted. Then again, it is sorted, correct? So in repeating numbers, as we use turn. No, it's not like that. In the repeating, like if the question would be till here 1 2 3 4 5 5 6 6 till here, we can use ternary. We can use the till here we can use the binary. But as this is the scenario where it is first time sorting in an increasing order, then again the decreasing order. In those scenarios, binary will create the problem. क्यों करेगा problem? क्योंकि you will not be able to understand. क्यों? See, binary में क्या था? First we will find out one mid and then we will go at one side. Correct? First we will find out the one mid, then we will go into one side. But यहाँ पर क्या है? यहाँ पर प्रॉब्लम हो सकती है. यहाँ पर प्रॉब्लम हो सकती है कि हम जैसे ही 5 के बाद आए और हमें 4 फाइंड आउट करना है, वो भी राइट साइड से. हमें ये वाला 4 फाइंड आउट करना है, वो भी राइट साइड से. हमें बाइनरी सर्च नहीं हेल्प करेगी, क्योंकि देखो 5 बाइनरी सर्च के according to binary search, once we find out the mid element, we can go for left only. We have to go for left. Correct? We cannot go to the right side. According to the binary search, we cannot go for the right side. So that's the problem actually. Once we reach, like let me share one slide. Where I seen this example. Let me share that screen. I looked into the Quora. Let me share it. Can you guys see my screen? Okay, great. You see the same example which I was talking about. If this is I was telling you the bitonic sequence, right? This sequence is known as bitonic sequence. So in the binary search, like once we reach the mid, now we are confused which side we have to go. We have to go to the left side or we have to go to the right side. That's the problem which we have. That's the problem we have with this sequence here. That's the problem we can have with this sequence. So that's why, what ternary does, ternary gives you 2 mid. Ternary will provide you 2 mid. You can see here, case 1, left mid or right mid. तो हम बस इसी के बीच में कंपेयर करेंगे. अगर हमारा जो एलिमेंट, जो टारगेट एलिमेंट है, अगर वो लेफ्ट मिड से छोटा है तो हम उस तरफ जाएंगे. अगर वो राइट मिड से बड़ा है तो हम उस तरफ जाएंगे. अगर वो लेफ्ट और राइट मिड के बीच में है तो हम वाले एलिमेंट को फाइंड आउट करेंगे. सिंपली यही है एक्चुअली. सिंपली अगर तुम टर्नरी सर्च के बारे में बात करो तो टर्नरी सर्च में क्या होता है? इन द बाइनरी सर्च वी डिवाइड इनटू 2 पार्ट्स. इन बाइनरी सर्च वी डिवाइड आवर एरे इनटू 2 पार्ट्स. Correct? First, we have to go on to right side or we have to go into the left side according to our mid. Correct? But in ternary क्या होता है? I'm just telling you the approach, guys, right now. I'm not implementing anything. Just telling you the approach. In ternary क्या होता है? We create 2 mids, mid 1 and mid 2. ये जो mid 1 होता है वो left side के पास होता है. यहाँ पे हमारा left है, यहाँ पे हमारा right है. कितना बड़ा एरे है? ये हमारा लेफ्ट है, ये हमारा राइट है. ये मिड 1 मिड 2, हम 2 यहाँ पे मिड क्रिएट करते हैं. इसके बाद अब तुम देख लो, इस तरीके से ऐसे बन जाता है. हमने एरे को कितने 1 2 3 ये वाली लाइन गलत है एक्चुअली, हम एरे को 3 पार्ट में डिवाइड करते हैं. Yeah, this line was wrong. Now you can see, just try to understand the concept. We'll talk the implementation also. Just try to understand the approach. So you see, this is the first place where we can search left and mid one. Second space is mid and right. Second, this one is the second where we search. And then third is here. So same logic. First we will find out अगर हमारा टारगेट मिड वन के बराबर मिड वन से इक्वल है तो हम फिर इसी को रिटर्न कर देंगे. अगर नहीं इक्वल है, छोटा है, तो इस तरफ जाओ. फिर हम चेक करते हैं राइट से, या मिड टू से चेक करते हैं. सबसे पहले मिड टू से चेक करते हैं. फिर सबसे पहले मिड वन से चेक किया, फिर हमने मिड टू से. विल चेक फिर द मिड टू. अगर मिड टू से बड़ा है, विल गो टू द राइट साइड. इफ मिड टू से छोटा है, हम इस वाले स्पेस में सर्च करते हैं, ये वाले स्पेस में. This is the approach only, guys. This is not the implementation. Just in your mind, just keep this logic. In the binary search, हम अपने एरे को 2 पार्ट में डिवाइड करते हैं बेस्ड ऑन 1 मिड. हमारे पास 1 मिड होगा, अपने एरे को 2 पार्ट में डिवाइड करेंगे. अब उस मिड के हिसाब से हम लेफ्ट और राइट जाते रहेंगे. करेक्ट. बट इन द टर्नरी सर्च वी विल हैव टू मिड, और अपने एरे को विल डिवाइड इन 3 पार्ट्स. Okay, we'll divide our array in 3 parts, and same, first we'll compare our target with mid one. If mid one is lesser, if the target is greater, we'll go on to the right side. If target is lesser, we'll go on to the left side. Same, then if both are not equal, we'll go for the mid two, and then we will check here. If mid two, if our target is greater than mid two, we'll go on to the right side. If lesser, go between the mid one and mid two. Okay, so that's the approach only. I know this could be a little bit confusing, because once I'm telling you this approach, you might be thinking some examples where you guys are going to implement it. So we'll see some examples about these, but yeah, just try to understand the approach till now. Okay, real life example, I think there would be real life example. I didn't find it out. I need to search some real life. You guys can tell me if you guys see any real life example of ternary search. Binary search, I think there are a lot of examples. Dictionary is there, book number is there, and there could be like most of the places we do the binary search only. But I'm just thinking about the ternary search. Where do you guys see any examples for ternary search where we need 2 people to guide us? It looks like we need 2 people here, mid one and mid two. And then those 2 people are guiding us where to go. Movie hall when it's dark. Ola. Yeah, like you guys can think, and we can talk about it tomorrow also. Yeah, you guys can think about the examples here, and then we can talk about it tomorrow. Sure. 2 different brokers for 2 different properties. No, property is the same hogi. We have to talk about same property. Then could be example. Because this is one array only where two brokers or where 2 people are needed. Yeah. Sunset, sunrise. Sunset, sunrise. Okay. If the size of data is large enough to make a difference. Okay, so we'll talk about it. You guys just think. I've just given you one topic to think about in your sleep or in morning. We'll talk about it tomorrow. Okay, for these examples. So now we will try to implement them in the JavaScript. Okay, with our slides. So before that, I think we can go for break. Right now it's 9:26. We can go for break. Yeah, sure, Suraj, sure. We can go for break, and we could come back at like 9:30, right? It's 9:40. We can come back at 9:40. Yeah, it's a 15 minute. Yeah, 9:40 or 41. Sure. So let me put that timer here. 15-minute timer. Let me share the screen. Yeah, timer has started. Is everyone back? Great, great. I think one more minute we will wait, then we will start. So you guys have any doubt till now? You guys can ask right now. In understanding the binary search approach or the ternary search approach or linear search approach. See, you should have first, like while you are understanding any algorithm, you guys should be having one what do you say, image in your mind that how this algorithm is going to work. So that's what we did till now. While we understood the approach, that's the image which we need to keep in our mind. That for the binary search, we need to divide our array into two parts, and we will divide it with the help of one mid element. Then based on the lesser and greater values, we'll go on to left and right side. Same for ternary, we'll divide our array into three parts, and then based on two mid, we will move left and right or in the middle part. For the linear, we do not need to divide our array. We have to fetch, we have to traverse all the elements. Okay. So that's what all about these approaches. Let's start implementing these approaches in JavaScript. Okay. So before that, how to decide two mid in ternary? Yeah, for that we have logic. Deepa, for that we have the logic. We have logic for us. For deciding it into ternary, for deciding it into binary, we have the logic for that. Okay, we'll see that logic. So before moving further, everyone, please create a new GitHub repo. I'm not sure if you guys have already created, then it's good. Otherwise, I am going to create a new repo, and whatever like files I will create, I will push it into that repo. You guys can copy the paste or check the code from there. Okay, so I'm going to create a new repo there. If you guys have not created it, you guys can also follow me. So you can see I came to the github.com, clicked on the new repo, right? Providing my repo name, so I can go get it like ds algo, something like that. Ds algo, yeah, name is available related to ds and algo in JavaScript. Correct? Yeah, it should be public so everyone can see it. README file doesn't matter. Git ignore, yeah, fine. Let's add a README, no problem. If we want to like something we want to write in README, which people can read later, that's why. Master branch, that's fine. Create a repo. You guys can also do that if you have not done. So this is my new repo. Now I'm going to clone it. Let's see, and I'm hoping I should not be facing any problem while cloning it. So I'm just moving to desktop. You can see I'm in the desktop right now. Can you guys see my screen now? Let me know in the chat. Can you guys see my screen? Great. So I will increase the size. You can see right now I'm in the desktop. And how I went there, I did CD desktop. In the last batch, we have discussed all about this, right? So let's clone it here. Git clone and put the repo. Let's see if I'm facing any problem to cloning. Yes, I am facing. It is saying please make sure you have the correct access right. So let's see, go with HTTPS. Let's see. This will also give us problem or no? Okay, finally, HTTPS worked for me. Okay, for you, it might be SSH. SSH could be working for you if you have provided the key, SSH key. In the last class, we have discussed about these things, right? About the cloning part, right? So I simply had cloned it. Now let's open this part in our Visual Studio Code. How we will open it? I already opened it earlier. So let's remove all these things. I was just trying to write these things before doing our class. So let's close all these things. Let's open a new Visual Studio Code. Okay, and let's open a new folder which I created. I clicked on open, clicked on desktop, and my folder name would be DSLO. Oh, I written the wrong name. It should be DSLGO. I written DSLog. Sorry for that, guys. Yeah, so now we have the folder here. So whatever changes we will do, we can simply push it. And now you guys can see it. So now everyone has opened this. Yes, actually. Why not? Create a new repo. You guys can share this repo with other people also, right? Okay, yeah, I forget to ask this question. Like whoever has done the last class, I'm sure you guys have pushed all the code in your GitHub. Have you guys shared that repo, like the code where you have into LinkedIn or in the like? Have you added those repos in your LinkedIn profile? Yeah, I think do that. You guys can share that repo in your LinkedIn URL, or you guys can simply create a post there that I have created this backend services. You can add the is a screenshot of Postman. I know there is no UI, but you can add the screenshot of Postman also. Okay, sure, yeah, please do that. That would be good, right? You guys learn something. You guys should show to others, right? That you guys have learned these things. You guys have developed one application in Node.js. Yeah, please do that, everyone. It will increase the chances of getting jobs little bit earlier. Yeah, sure. So same here also. So create a new repo, which you guys can later share in the LinkedIn or any other platform. What to select in Git template option? Template option was there. Let's see. Oh yeah, this is the Git ignore template. You can select node here. It tells us which language you are working. According to that, it will put things in the Git ignore. You see, according to JavaScript, there would be node modules, typings, .npm. These things will come. If we'll put Java, so I think according to Java, things will come. That's why there it is asking about the template. Okay, Sarath? Node is fine. Okay, guys. So let's create a first file here where we are going to write the linear search. So I will give a name like linear underscore search dot js. Okay. In this file, we are going to write the linear search. Okay. So please, everyone, create a new file and give the file name as a linear underscore search dot js. Okay. Arad the node. Yes. What is the mean? No. Okay. So I think Arad is answering Sarad. Yeah, it should be node. Okay, so now, yeah, understood. So now everyone, so now if you have already, okay, so everyone has created it, new file, let me know in the chat. Yes, Arad has created it. Yeah, linear underscore search and .js, just to understand our file name better. That's why we have given the linear underscore search.js. Somebody wants to speak, it's Nishant, okay? Let's see. Yeah, Nishan. Oh, okay. I think mistakenly. Oh, that's fine. That's fine. Okay, so everyone has created a file now. So now everyone now see into my screen. We will now going to implement linear search with one array. Okay, let's try to see. Let's try to see there. Okay, so let's take one. I'm just adding one comment that this is going to be linear search. Linear search. Okay. In my VS Code, my folders and file deletes automatically. Ah, that happens sometime. Yeah, it could not be automatically, right? Some computer could not do things automatically. Somehow mistakenly you have deleted it, right, Joseph? But yeah, that's fine. You can create a new folder and start this thing. Okay, Joseph? And I think you already have things on Git, right? GitHub, so you can clone from there all the things anytime. That's why that's why GitHub is good, right? It's a remote repo where you can keep all the things. Nobody is going to delete it there. You will create your or your like in your account. So those that though nobody can delete it. Only except hacker. Hacker can do whatever they want to do. But yeah, like if you are not providing any other people's permissions to edit or create a new files, nobody can delete it in GitHub except you know that, right? Okay, let's come back here into the linear underscore search.js. Sir, can we do search with recursion to know the concept? Sure, we can do that also here. I think with the binary search, we'll try to do that. But yeah, let's see. First, we'll do the iteration. Then I think we'll try to do the searching here also. But I think, yeah, I think recursion could we also do with the linear search also. That's right. But yeah, let me think. For linear search, I think iteration would be very easy because see, in the recursion, when we talk about recursion, two things are very important. If we talk about the recursion, two things are very important. One is the termination condition, yeah, the base case or the termination condition. And the second thing is how to pass values in the same function. क्योंकि देखो recursion, what is recursion? Recursion has two things. Call the same function again and again with base condition. This is recursion only. Call the same function again and again with base condition. Because with that base condition only, we are going to stop the function calling. क्योंकि हम बार बार फंक्शन को कॉल कर रहे हैं, हमें एक बेस कंडीशन चाहिए जहां पर हम अपने उसको क्या उसको बेस कंडीशन को रोक सकें. एक्चुअली यस, हम कर सकते हैं. अभी मेरे को आइडिया आया, हम लीनियर सर्च में भी कर सकते हैं. विल ट्राई दैट. ओके, विल ट्राई दैट विद द लीनियर सर्च आल्सो. यस, बेस केस बिकम्स अ टर्मिनेशन. यस, दैट्स राइट लिंजन. क्योंकि रिकर्सन का सिंपल मतलब है, रिकर्सन मीन रिकर्सिव, समथिंग इज हैपनिंग अगेन एंड अगेन, अगेन एंड अगेन. So now you need some termination of base condition, which you are saying the base condition. I generally say is at a termination point. With that termination point only, your function calling will stop. Otherwise, if you will not provide termination condition, it will continuously call it. And at the end, in JavaScript, you will get like stack call stack exceeded maximum limit. Some errors like that. You will get it. Okay, so we'll show it. We'll show it. Okay. So let's see. First, we'll go with the iteration approach. Okay. So let's see, guys. Everyone. So we're taking one array. Let me increase the size also so everyone can see it. We are taking one array, or let's say because in linear search nothing matters. So you can take anything. 1, 4, 7, 9, 2, 4, right? 2 and like 6. Correct? This is the linear search. And second thing, our target. We are going to look for 9. हमें इसका index चाहिए. What is the output which we are looking here? We are looking for the index. Which like if my element exists in the array, what is the index? Okay, so very easy. I think we all do that. So first is the iteration approach, right? First is the iteration approach. Iteration means we are going to use for loop, while loop. These are the iteration mechanism, right? Where we use for, while, or while, or there is one more, right? For each. For each is there. These type of things where we are doing the iteration. Yeah, do while. Yes, that's what I was thinking about. Do while. Correct. Thanks, Vishal. So yeah, so this is our iteration approach. Iteration approach. Okay, so first iteration approach, very easy. Like we'll use the for, simple. For let I is equal to 0, I less than equal to array dot length, तो उसके 0 से लेंथ तक चलेगा, और I प्लस प्लस. करेक्ट. अब हमें वेरी सिंपल, हमने लूप चलाया, हमारे हम एक एक एलिमेंट को रीड करेंगे. अब हम जैसे ही एक एक एलिमेंट को रीड कर रहे हैं, we'll do array and we'll put our I index there and we'll compare it with our target. If target is reaching, we can simply return it. It's not function, so we can simply console it here. Console.log. We'll say our index, simply index for target is I. We can simply do that. See guys, this is how to access array element. देखो I यहाँ पर index है, यहाँ पे जो हम I का iteration चला रहे हैं, that is index. And how to access element in array with the help of indexes, we do array I. You can see, very simple. This is very JavaScript concept. If you guys have forget, I'm just revising it again. If you want to access element in array, we just simply do array 0. We'll get 1. Correct? If we do array 1, we'll get equal to 2. Correct? That's how we access element of an array. And that's what we are doing here. But here we are dynamically reading it. We are not providing 0, 1 statically. We are dynamically reading it. And that's how we are dynamically reading it, with the help of for loop. हमारा लूप 0 से स्टार्ट हो रहा है, कब तक चलेगा? array dot length. और array dot length would be, everyone, array dot length would be 6, right? Array dot length would be 6. अब ये लूप हमारा 0 से 5 टाइम चलेगा. क्यों? क्योंकि हमने लेस देन लगाया है. 0 से 5 टाइम चलेगा. अगर हमने इक्वल लगाया होता है यहाँ पे, if we put equal here, this loop will run 0 to 6, which means 7 times. Correct? This loop, if you will put the equal here, then this loop will run like this: 0, 1, 2, 3, 4, 5, then 6. Correct? So you can see how many times this loop has run: 1, 2, 3, 4, 5, 6, 7. 7 times. Correct? But now we are putting less than. So now this loop will run only 6 times. So every time we will take the new index, and then we are comparing with the target. And once we have reached our target, we are saying this is the index. This is very simple linear approach. Let's run it. And how we'll run it? You guys know it. Node and linear underscore search.js. Very simple. We have done these things in earlier bad classes also. So no need to talk more about it. Yeah. So linear node, linear search. Let me see first. You guys can see my screen or not? You guys can see my screen? Okay. Because I remember in the first class of last batch, I was just talking and nobody can see and hear me. Yeah. So yeah, so let's run it. You see, index for target is 3. Correct? Now we can do like here 2 also. Or like, no, what was that? Yeah, target, sorry. Yeah, we can look for target as a 9. Correct? Index for target is 3. Okay, what happened? Yeah, 0, 1, 2, 3. Earlier, what was that? 7, right? Earlier it was 7, right? Okay, let's remove this one. For 7, it is giving 3. Oh yeah. 1 minute. Let me print a target also. Index for target is, now we'll print a target also. So we'll clear, right? Target and index. Yeah, now you see 7 is our target and index is 2. Same we can go for 2 also. So see, there is 2 elements for 2, right? 2 comma 1, 2 comma 4. That's why both indexes are coming. First time we find 2 as first place, second time we are finding it as a fourth place. Correct? Same way, this is very simple approach. 6, look for 6. See, 6 as 5 position. Correct? So guys, in the linear approach, हम अगर वर्स्ट सिनेरियो की बात करें, वर्स्ट सिनेरियो क्या होगा कि हम एलिमेंट में हम गए ही नहीं, हमारा ऐसा एलिमेंट जो हमें मिला ही नहीं. अब इस केस में क्या होगा, देखो हमें कुछ नहीं मिला, राइट? तो इस केस में क्या होगा, इट विल इटरेट होल एरे, it will iterate whole array. So like whatever array length is at that time we will iterate it. So इसका जो time complexity होता है linear search का, the time complexity for linear search is n, where n is the length of array, where n is the length of array. Because हम हमें जब तक एलिमेंट नहीं मिलता है, हम उस पूरे एरे को इटरेट कर रहे हैं. We will traverse each element in that array. That's why the time complexity for linear search is n. Okay? Yes, it's n. Correct. Okay. So some while I was going through the slides, they were also talking about the global linear search. There is one term there they have mentioned that's called global linear search. So global linear search, simple meaning is if there are many elements, like 2 is there, so we have to provide both of indexes, and that's what we are already doing. We have provided both of indexes for element 2. Simply we can create an array, like as I was seeing in the slide, they've created one index array. We can say indexes. This could be our array. And here, rather than printing it out, we can push those indexes. Indexes dot push I. We can simply push those indexes. Now, at the end, we can print. For checking, we can print our indexes array. Indexes. Yeah. Now we'll see. Index is empty because there is no element for 5. Let's look for 2. 3, 1, 4. That's what the global linear is. Same thing here. If we global linear means simply if we are having multiple elements here, then provide index for all the elements. That's what is happening here. Okay, guys. Space complexity is n actually. Space complexity is simply n because space complexity is 1 because we are not doing anything. We are not creating any new space. I think now this indexes could be the new space which we are creating. Otherwise, array is already created, target is already created. These are like execution is happening. We are not taking any new space. New space only taking for indexes. And this indexes could be simply like one index could also be there, or 2 indexes could also be there. So it will depend on that part, the space complexity. Okay. So you see, Suraj, space complexity, or generally, see, it was very earlier concept when people talk about the space complexity, right? Because now earlier we do not have that much space in our systems. So that's why we try to reduce the space. But now we have a lot of space. Now we are talking about GB, right? Or terabytes we are talking about. So that's why space complexity people does not ask in the interviews. But still, if people are asking, so space complexity, you need to find it out how much, like while doing the calculation, while doing the while looking for the solution, how much new space you have added, how much new space you are adding. Like in some of the scenarios, you create new object, right? In some of the places, you create a new object. So object take a lot of space in memory. But in this scenario, if we remove the index part, if we remove this index part, you can see there is no space we are using. We are just simply declaring the variable and doing the iteration here. So it's simple. 1, there is no space at all. This array already created, so nothing matter. But see, time complexity and space complexity only calculated when we are trying to find out, when we are trying to write our logic. And in this place, I think we are not using any space at all. But if we talk about the global linear index, so I think for storing our indexes, we are keeping some of the space. We are taking some of the space here. We can say that like whatever indexes are coming, that much space we are taking. And that could be negligible also. That could be negligible also. Okay. If there were no space taken, then space complexity will be O1. Yeah, it will be constant. O1 means constant. Like there is nothing happened. That's what. Can you explain again about the space complexity? See, space complexity is how much new space, how much extra space you are using while doing the iteration, or while trying to find out the solution. How much new space you are using. I remember in the case of object, when we are when we are trying to give any solution, and at that time if we are using object, so that object takes lot of space. At that time, the we think in some ways that somehow we can reduce the, somehow we should not be using the object, because object may take lot of space in memory. So that's, on those scenarios we simply create the space complexities. But in our current problem, in this problem, I think we are not using at all any space. We are just simply doing the calculation here. We are just simply comparing it here. We are just simply calculating the length, and then right, like after adding the indexes, we can say that whatever the length would be for this index array, that much space we can say that would be needed in the global linear part. Yes, using a new array or object. Yes, that could consider under the that could be considered an extra space which we are using to do the solution. Correct. Yeah, extra space in sense, you can see the indexes here. We are taking the extra space to just to figure it out, like keep all the indexes at one place so we can use these indexes later. Or sometimes we create the object to to use that object later in our calculation. Those in that sense. Okay. In what respect, what is extra space? So how do we find it in extra space taking? Yeah, that's how. See, indexes, this is the extra space we are taking here. In the same way, some places you might be using the, like some extra variables, I would say. Those could come also under the extra space. Some places, I think the concern where people talk about the extra space, that comes with the object. I have seen when you're taking any new object in your problem, in those scenarios people talk about how can we reduce these space complexity. But all other places, I think that doesn't concern people. Okay. Yes, indexes will be extra space here. That's right. Wires and arrays can be considered extra variables, or arrays can be considered extra. Yes, yes. And I could look for it, and I could bring some more examples where we can see for some extra spaces. Okay. I could look for that and bring some examples for you guys to understand, so we can understand, we can properly understand the space complexity. Sure. So that was, guys, about the linear search. So let's read in the slide quickly if we have missed anything here, which is not covered in the slide. So I think this is the problem they are telling in the slides. Let's move further. Yes, for objects, space complexity is high. That's right. Because objects take a lot of space in memories. So yes, for space, it takes complexity. So yeah, so they are saying, yeah, key value. That's right. So they are saying for linear search, it's a brute force way that everyone can think of it. Brute force means we are just brute force means like सबसे हमें पूछना है. In similar words, everyone, whatever data is available in array, I will ask to everyone. and that's what we are doing in linear. हम सबसे पूछ रहे हैं, we are going to each elements in that array. That's what the brute force is. So brute force way that everyone can think of it is a, let's start from the beginning of input array and traverse it. We check whether the current element is same, then the same, it is going in the same. Whatever we did, that's what is written here. Nothing new. You guys can read about it. Thanks, Sangeet. Native approach. Yes, it's a native approach. That's right. Then I think they are talking about like code. They're talking about their code. We can initialize a variable. We can write things in many ways, right? That's what they're explaining here. Okay, they have given one example. We'll see that example also very quickly. We can't click on here in this link. Okay, 1 minute, guys. I have the URL. Let me share it. I have opened the slide here also. Yeah. You guys can see my screen, right? Let me first see the chat. You guys can see? Yeah, okay, great. I'm just going through the slides, guys, so I have not missed anything. So let's see their URL, their code URL also. So you guys can later refer it. Is there anything new? So they have created one function here, linear search, passing array, passing the target. Yeah, they're doing the same thing, guys. They're comparing it. Rather than doing the console, they are simply returning it. See here, no space complexity. Bilkul 1, it's a constant. Nothing is using here. No extra space. Right? And time complexity is n, because we have to iterate whole array. Correct. So let's see if we are missing anything else. Then yeah, global linear search. Yeah, that's what I was talking about. We don't value after we come across the first element we're looking for. But what if we want to find the indices of all the occurrences? Yes, global linear search is if you are trying to find any target, for that target, if there are many occurrences, like in the case of 2, right? In the case of 2, we might get multiple occurrences. So that's what, how we will represent them. That's what I think they are pushing it into the array. You can see they have created a new space here, and in that space they are simply returning all the indexes. Very easy for everyone. Correct. Let's move further. Then they are talking about the complexity of linear array, linear search, and the upper the complexity is O(n) in the worst scenarios. Space complexity is 1. Correct. We are not using any extra space here. Okay. Yeah. Then jump into the binary search. So let's try to first read some slides. Then we will try to implement it. Okay. In meanwhile, let me see if any questions you guys have. To console it, you need to take the extra space. To console it, you need to, yeah, I think yes. That's right. To console it, you need to take extra space. Definitely. See, these type of spaces are negligible. See, while we're talking about the computer, lot of things we consider as the external, जो कि हम कंसीडर ही नहीं करते हैं कि हम इस कैलकुलेशन इस एल्गोरिथम में कैलकुलेट करें. क्योंकि देखो क्यों नहीं कैलकुलेट करते हैं, बिकॉज राइट नाउ वी आर ट्राइंग टू क्रिएट दिस एल्गोरिथम फॉर स्मॉल मशीन. But if we talk about the supercomputer, those machines are too much powerful. So these small space or these small time, they will not matter there, right? So that's why a lot of things while writing in algorithms could be considered as a external, like dependent on external in your machine. Like in my machine, my RAM could be small. So I like 1000 element, like if we have array of 1000 element, if you want to find something, it could take, I think, 2 minutes because my hardware and memory is small, less. Correct. But if in case of your machine, like if you have 4 GB or 16 GB RAM, that the same 1000 elements could like easily in seconds you can find the target there. So that's why some of the things are external there, which we do not consider while writing the algorithms. Okay, guys. Yes, mostly questions they ask about the time complexity, and they only focus on time complexities, that you should not be having a time complexities which should be going n square, n cube. No, they should be mostly the best time complexity. People say it's a log n. I think binary search provides you log n only. Right now you can see in the linear search you are doing n, right? But in the binary search you will see that like you will use less iteration to get the result. Okay, let's see. Let's move further. Let's see our slide and let's move into the binary tree. Okay, guys. So see, there is some like very difficult words to understand the binary search. But yeah, let me quickly read them. But no need to like remember these things. Nobody is going to ask you about the binary search. Like tell me the definition of binary search. I have not faced any of the scenario where they're going to ask you about the definition of binary search. They always ask you the approach, how the binary search works. But yeah, let's read it. So they're saying it's very simple, intuitive, efficient searching algorithm. The important word is here monotonically. See, these are very guys. Just under like read these terms and do not like if you didn't understand, that's okay, that's fine. Nobody is going to ask. These are some mathematical terms about to understanding these things. They're saying see, they are also saying the better and more mathematically correct statement would be binary search is applicable on monotonic sequences. And see, guys, monotonic sequences is similar to the sorting. I was talking about the sorting. Wherever array is sorting, wherever the sequence is sorting, those sequences are called monotonic. Or there, I told you, right? Biotonic was also there. While we were seeing this example, they were telling about the biotonic, right? There was one word, yeah, biotonic sequence. Biotonic sequence looks like this, where they are going into this way, then coming back, then going up, then coming back. This is biotonic sequence. But monotonic, एक ही direction में जाएगा. Monotonic, it will be going to increasing or in decreasing. That's the sequence. These are only the mathematical terms, guys. Do not be confused with these terms, or no need to remember these things. I was just reading first time these terms actually. Yeah. So you see, they are also explaining it. What is monotonicity? The monotonicity is of function tells if function is increasing or decreasing. I don't know why they are making this much difficult to read. They can simply say the sorting here, right? See, they are again telling the monotonic function increase in its entire domain or decrease in its entire domain. Same. XY axis, guys, it will increase or decrease. They are telling this XY axis as a domain. What is non-monotonic function? Which is not increasing, not decreasing, means unsorted. Unsorted arrays which are not increasing, not decreasing. Those are non-monotonic functions. They are telling these things in the functions, which is like mathematical functions they are talking about here. Okay. Okay. Then they are giving us the examples also. The one is monotonic is typically increasing monotonic. Yeah, it's like default increasing, decreasing. This is not monotonic. It could come in biotonic, you know. These third and fourth could come under the biotonic, as we see the biotonic here. So I think the third and fourth would come in the biotonic, right? See, they have not mentioned about the biotonic, but we are still talking about biotonic. Funny. Okay, so now what they're saying, binary search. Okay, so yeah, so binary search is also known as, this is a nice thing actually to remember, divide and conquer algorithm also. You know, divide and conquer. If you guys like it's a political term also, right? Divide and conquer. Like so many people say that British has done this, right? The the divide and conquer. They do it in each countries wherever they go. So they did the same with us also, right? They divided us on a religion until still we are seeing the consequences of that. The same way the binary also works, right? It just divided. It has divided it into two parts with one mid. With one mid, it has divided into two parts. Correct? One is the left side and one is the right side. Correct? And now based on that mid, we only decide where we have to go. Based on that mid, we have to decide where we have to go. So that's what this algorithm is also known as divide and conquer. But yes, this term is good. People could ask, what is divide and conquer? So yes, this is monotonically, and yes, those terms nobody is asked. But yeah, divide and conquer algorithm, binary search algorithm, these terms you guys can remember. Same for linear search, sequential search. These terms you guys can remember. People sometimes they ask. Sometimes they ask means they will say you do this problem with divide and conquer. They can ask, they will say in that way. Ankit is saying these quotes are never set for the Britishers in the world. Very deep quote. Huh? They are still, I see, yeah, that's another topic to talk about. But yeah, they are still doing the same they were doing earlier. They're still doing the same. So that's what. Let's move into our topic. Let's not talk politically here. Okay, so yeah, divide and conquer algorithm. They are again telling it divide the array roughly in half every time, and then we continue the algorithm in favorable search. Okay, that's fine. We have already seen that. Okay, then they are telling the examples. That's fine. Okay, let's take their example and let's try to implement it. Okay, looking for 18. So let's create a new file, guys. binarysearch.js binary underscore search.js. अब हम टेक्निकली बाइनरी सर्च को करने वाले हैं. अभी तक हमने अप्रोच टिल नाउ वी हैव अप्रोच, we have understood the approach. Now we'll implement it. Yes, the coding part. Okay, now we'll see how we are calculating mid and those things. Okay, so guys, I have seen like, okay, let's first implement the ways. Okay, so let's first take the array const arr. Let's take same array which they have taken in slides. So very quickly, it's a big array, but that's fine. 1 2 5 7. What is next? 13 15 16 18 24 28 29. Sorry, looking for 18. So yes, so first our target, we also know the target, which is 18. Correct. और हम एक फंक्शन बनाते हैं गाइस. What we did earlier, we have written everything in the main file, but now we'll create one function. Main file में भी लिख सकते हैं, but we are just because we are going to implement many things here. So हर बार सेम कोड रन हो, उससे बढ़िया है कि हम फंक्शन बनाते हैं, है ना. फनी सर जो कि एक एरे लेगा, which will take one array and then it will take the second target. Now we'll call this function down, binary search, and we'll pass our array and target. Very easy thing, right? Array and target. We are simply calling our binary search, and I will put console also. So whatever result is coming, we can simply see it. Okay. So till now we are good, right? Let me see in the chat. Are you guys able to see me? So we'll be doing recursive way. Oh, recursive way, we miss it. Okay. Yeah. Okay, so guys, if you want, okay, let's do the recursive way in the linear search first. Okay, sorry for that, I missed it. So let's see, guys, just wait for binary search for 2 more minutes. Let's do the recursive search here also first in the linear search. Okay, and let's comment out this iteration approach for some minutes. Okay, let's do the recursive approach. So in recursive approach, we always need to remember two things. One is the termination condition, and second time we need to call the same function. Recursive always work in function. So first let's create a function. So function, very quickly I will do linear search. Okay, I'm also doing it first time, so let's see that. So see, we need two things here. So first let's pass our array comma target. We always need to pass these two things, right? Array and target, right? And let's call it linear search and pass our array and target. Array, comma, target. Guys, always recursive approach always works on function. For recursive approach, you always need to create one function. After creating function, you need to immediately think about the base condition or termination condition. Okay, you quickly need to think about the termination condition. अब हमें termination condition क्या मिलेगी? So our termination condition could be yeah, I think our termination condition could be we need to pass one more variable from here. That would be count. That's how do you write the recursive function. Once you write the recursive function, then you need to think about your termination condition first. Where, how will you stop this function to run? Now our count will start from 0. देखो मैं क्या सोच रहा हूँ, मेरी अप्रोच क्या है? I am thinking about I will stop this function when my count will be equal to my array length. जैसे ही मेरा count इस array length के बराबर हो जाएगा, I want to stop this function. Okay, very easy. I will increase count every time, and once my count will reach to this actually will be equal to array dot length, I will stop it. That's what I'm thinking right now. Okay, so let's do this. Let's write our condition. If array dot length equal to count, I think this could be our first termination condition, and we can simply return -1. Because if it is reaching array dot length is equal to count, it means we have not find any element. It means we have not find any element. Yes, am I right? Because if we are reaching this condition where our array dot length is going to be equal to count, it means we have not find that element. Okay, now second condition would be if array count will increase one by one equal to target. It means we find our target, so we will simply return that count. Okay, अब देखो मैं दोनों कंडीशन लगा दी. ये कंडीशन है तब के लिए, this condition will work when we have not find any element, when we have not find our target. So I think हमें इस कंडीशन को पहले लगाना चाहिए, right? Because it could be the last, right? It could be the last element which we are looking for. So अगर हमने पहले ये लगा दिया, guys, why I kept it as a first condition? Because अगर हमारा लास्ट एलिमेंट है जो हम टारगेट को फाइंड आउट कर रहे हैं, तो ये कंडीशन पहले रन हो जाएगी और हम रिटर्न -1 हमको मिल जाएगा. So that's why I kept it this condition first. If our last element is also matching to the target, we'll return that count. Otherwise, if nothing is matching, we'll simply return -1. Now we'll simply we'll call the same function. This is the second thing for recursion. We have to call the same function. We have to pass the same array. We have to pass the same target. And now count +1. हमें count एक एक करके increase करना है. Count +1. Correct? So we'll simply return it. This is the recursive approach. Let's see if we have made any mistake or not. We'll see. So here we will print the result. Here we'll print the result. Okay, guys. Also, if array is empty, it will also be -1. Array dot length. Yes, array dot length is equal to 0. That's true. That's true, Nilanjan. What happens if we don't return that? Yeah, no, we have to return it. Otherwise, see, if you will not return this function, once this function will execute, it will not know what data we need to return to the previous function. See, you know what is happening in the, let me show. Okay, first run it, then we will answer that question. Let's see first if we made any mistake here or not. Let's see. What is the array we are passing? We are passing this one. And let's first look for 6. Let's see the 6th last element. It should be 0, 1, 2, 3, 4, 5. Let's see, are we getting the result or not? Result is 5. Let's look for a 9. It's a 3. Is it correct? 0, 1, 2, 3. Let's look for now 2. Let's see what will happen in the case of 2. Here. It has given only the first index. As it is matching first time, it is just returning from there. Okay. So first let me push these changes. I push these changes so you guys can later check it from there. Okay, now 1 minute. Let me see first any of the question. What happened? Yeah, Likit, I will answer that one. Is it nor array dot length -1 array dot length -1? नहीं नहीं हमें array dot length -1 नहीं करना है. Oh yes. I think yeah. 1 minute. Yeah, that's a good question. That's a good suggestion. That's a good point actually. I would say because array dot length would be 6. Array dot length would be 6, and our count we are starting from 0. Oh, that's right. I think it should be array dot length -1. That's true. That's true. I think. No. Likit. I think array dot length -1 would help us, right? Because see, 6 minus 1 is equal to 5, and count would be 5. See, first time 0 would be there. 1 minute, let me check. First time 0 would be there. We will be checking the 0 here, correct? Then we will saying that 5 minus like 6 minus 1, 5. 5 is equal to 0. No. Then we are increasing it 1. Second time, so see, first time 0 will come, correct? Second time 1 will come, correct? Compare it here. So like array dot length will be 6 minus 5. So this will be the first pair. 5 comma 0. Count is 0. This is the first pair. Second pair would be 5 comma 1. Second iteration. Third iteration. 5 comma 2. Right? Fourth iteration. 5 comma 3. Right? 5 comma 4. And then 5 comma 5. बस अब देखो ना, तो हमने ऑलरेडी 6 एलिमेंट वी ऑलरेडी ट्रैवर्स इट 1 2 3 4 5 6. नाउ व्हाई वी नीड वन मोर इटरेशन? I think that's right. It should be array dot length -1. What do you guys suggest? Array dot length might also be maybe equal to target. Then in that case we cannot return -1. -1 also, but one minute. Like it is saying we have to keep greater equal. He's saying we have to keep greater equal. Oh, you mean okay? But why? Yeah, greater equal will also work. Greater equal will also work. Yeah, like it. If the element is at last, then it will not terminate. If the element is at last, then it will not. See, if the element is last, it will terminate from here. If the element is at last, like if the element is 6, it's at the last index, it will automatically terminate from here because we are returning count from there. Right? Try to return -1 condition. Okay, let's see. So, okay. So let's try to return 5 from here. Let's see what will happen now. 1 minute. Yeah, it's a result -1. Sorry if the element is not, if target is 3, yeah, that's what, target is 5. Yeah, it will work, guys. It will work. Greater equal will also work. Greater equal, this condition will also work. Greater equal, yeah. This one will also work. See, result -1. and triple equal will also work. Okay. Okay, so that's what. Okay, let's come back to. Okay, like if the element is last, then it will not terminate. Get it? Explain the more times. Kept last element, then we will print both. Keep. I think is for the code position. Keep last element, then it will print both. Keep last element, then it will print both. Okay. No, 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 that will not happen. That will not happen, Likhit. That's what you're saying, right? Oh, okay. 1 minute. You're saying if we will keep the last element target. 1 minute. Okay. Hmm. No, I was expecting it should be written from here. In that condition, it should be written from here. Then why it is going here in this part? 1 minute. So the last condition would be count would be 5. 1 minute. Let's print the count very quickly. Let's print the count very quickly. You will understand this. Yeah. Count is 0. Oh, okay, directly. Oh, sorry. I just made the wrong condition. Yeah, it should be triple equal, right? I made it greater than equal to. It will always be greater, right? So it will. That is wrong condition. It was earlier. You see, now return is result is 5. That's what I was trying to explain. It will return from here only. Return count. Okay, Likit? Yeah, this see if see this condition I made it wrong, greater equal, that is wrong actually. Yeah, yeah. So see, Nilanjan, for writing any recursive function, you need two things. One is your termination condition, and second one, you have to call the same function again and again. That's the two things you need to remember. Okay. Once you remember these things, now you just need to implement it. अब देखो क्या हो रहा है? You have created linear search, and now you before this is a function which we are going to call again and again. Correct? It's a recursive approach. Like same like iteration, you are writing for loop. This is also internally it's recursive only. Correct? This for loop will be wrapped in some function, and then this thing happen recursive only. Correct? Now this is the condition. These are the two conditions where our function calling will stop. Where our function calling will stop. Okay, let me show you one more thing, guys. That will help you. Let me come back to slide part. Okay, let's see. We'll write here our linear search method. The first time when we call the linear search, I'm just simply writing LR to make some extra space here. Okay, I'm just writing LS. Correct? This is the first time we are calling. Like first time. Where count is 0. करेक्ट काउंट इज 0. फर्स्ट टाइम हमने कॉल किया एलएस को, लीनियर सर्च को. अब लीनियर सर्च ने कंडीशन अपनी चेक करी, काउंट वाली चेक करी और लेंथ वाली चेक करी, दोनों चेक कर ली और उसमें कहीं नहीं गया. उसने रिटर्न किया दूसरा लीनियर सर्च फंक्शन. करेक्ट? ये सेकेंड टाइम. नाउ काउंट विल बी 1. करेक्ट? काउंट विल बी 1. ये इसने रिटर्न किया. अब यहाँ पे फिर से हमने एलिमेंट चेक किया, टारगेट चेक किया और लेंथ चेक करी, फिर से काम नहीं बना. अब जैसे अगर हम सेम ही एग्जांपल ले लें तो हमारा एग्जांपल क्या था? 1 मिनट में ले लेता हूँ एग्जांपल. 1 2 7 1 2 7 9 2 6. हम 6 के लिए जा रहे हैं, हमारा टारगेट है 6. ठीक है, हमने काउंट 1 चेक किया. काउंट 1 में हमारा ये 0 इंडेक्स था, ये 1 इंडेक्स था, ये सेकेंड इंडेक्स था, थर्ड, फोर्थ, फिफ्थ, हमने फर्स्ट इंडेक्स चेक किया, हमें अकाउंट में कुछ भी नहीं मिला. हमारा जो अकाउंट है ना, इट इज वर्किंग एज इंडेक्स नाउ for our array. Okay, this count is working as index. Now this also didn't work. Okay, now internally we are again calling the linear search. Third time we called. Now our count become 2. Again no match. No, क्योंकि हमारा सेकेंड इंडेक्स पे 7 है, नहीं मैच हुआ. फिर से हमने लीनियर सर्च कॉल किया. काउंट हमारा क्या था? 3. मैच, यहाँ पे 3 मैच हो रहा है, नहीं हो रहा है. फिर से हमने लीनियर सर्च को कॉल किया. ठीक है, हमारा काउंट क्या था? 4. मैच हुआ, फोर्थ एलिमेंट नहीं हुआ अपने टारगेट से, हमने कह दिया नो. हमारा फिर से लीनियर सर्च, अब हमारा काउंट 5 हो गया. काउंट हमारा 5 है. अब यहां पर ही तुम लोग कंफ्यूज थे. यू वर कंफ्यूज हियर, बट आवर फर्स्ट कंडीशन इज इन दिस प्लेस वेयर आवर काउंट इज 5. आवर फर्स्ट कंडीशन वाज check the target. Target is matching or not. But yes, in this case target not matching, so we'll simply return from here, from this ls6. We will not go for -1, we will not go for the second element. अब इसने इस फंक्शन ने 6 रिटर्न किया, अब ये फंक्शन भी इसको 6 रिटर्न करेगा, ये फंक्शन भी इसको 6 रिटर्न करेगा, सॉरी 5 रिटर्न करेगा. हम इंडेक्स को रिटर्न करा रहे हैं, ये फंक्शन इसको 5 रिटर्न करेगा, ये फंक्शन इसको 5 रिटर्न करेगा, ये इसको 5 रिटर्न करेगा, ये इसको 5 रिटर्न करेगा, और ये इसको जहां हमने फर्स्ट टाइम कॉल किया है ये इसको 5 रिटर्न करेगा. ऐसे ही तो फंक्शन कॉलिंग होती है. इन दिस वे वी कॉल द फंक्शंस, राइट? Functions always return us, right? Return the results to us. This is like nesting of function. You can see recursion is nesting of function. That's why two things need to remember in recursion. One is nesting. Call की nesting हो रही है, देखो ना तुम यहाँ पे. This is like nesting, right? One linear search is calling another one, then this one is calling another one, this is another one, this one another one, this one. And if you will not provide any termination condition, ये continuously होता जाएगा. That's why termination condition is very important. Okay, that's why the termination condition very important, and that's why we provided 2 termination condition, which was where the target is matching with array element, and or the second condition is अगर हमारा array length complete हो गया है, अगर हमारा array length count के बराबर आ गया, array length -1, सॉरी array length -1, क्योंकि हम count को 0 से start कर रहे हैं, इसलिए array length -1 is equal to count. Okay. So Hariharan is saying if count is equal to array length -1 and array count is not equal to target, array count is, will this work sir for second? Yes, this could also return -1. This could also return -1, Hariharan. Okay guys, are we good with recursion? I think I have not given you more examples on recursion. I thought we might have any or more slides on recursion in the further classes, but I hope you guys get some idea about the recursion, right? Nilanjan, Vishal has got it. What about you, Nilanjan? What about others? Like, what is confusing? I know recursion is little bit confusing, but yeah, how I remember it only with 2 things. I somehow, like if I'm writing anything in recursion, I have to be find best termination condition. That's how you start with that. Yeah, we can understand with more examples. That's right. Let's quickly look into our binary search, guys. Okay, let me share my screen with the iterative approach. We'll go with the iterative approach. Okay, so now we have our binary search method. You guys are able to see my screen, right? Okay, great. So like what we have discussed in binary search approach, we have discussed we need to find it out the middle place. We have to find it out the middle place. So the logic for that is, so first we'll write our left. In this array, we have this left position, this right position, and then mid. So I told you, left would be the 0th index. Let right, this would be our right last index. which would be array dot length minus 1. Correct? These are the two things which we have calculated earlier. Sir, I'm able to solve the easy problem, but the hard problem are too much in recursion. Yes, actually, dynamic programming, yeah, there we use the recursion in very complicated way. But yeah, I think with practice only we can like solve these problems. Sometimes, you know, we start with the recursion and it is just 2 to 3 hours just go like this while solving dynamic programming on these type of problems with recursion. So yeah, I think recursion helps us to solve some difficult problems also. But yeah, we need practice for that. Okay, coming back to this binary search here, guys. So now we have our left, we have right. Okay. Now, guys, we need to put one condition here. करेक्ट. और हमारी कंडीशन सेम रहेगी जब तक हमारा लेफ्ट राइट से बड़ा ना हो जाए या हमारा राइट लेफ्ट से छोटा ना हो जाए. कुछ भी कोई भी कंडीशन लगा सकते हैं. तो दिस वुड बी आवर कंडीशन व्हाइल लेफ्ट लेस देन और इक्वल टू राइट. तब तक हम यहाँ फॉर लूप नहीं ले रहे हैं, हम यहाँ व्हाइल लूप ले रहे हैं. बिकॉज व्हाई वी आर नॉट टेकिंग फॉर लूप? Because we do not need that iteration, like we do not need that I index. Correct? In I index we use in the for loop. Here we are going to calculate the mid, right? That's why we are not taking the for loop. We are taking here while loop, and we are saying run this while loop till left is equal to right or left is greater than right. और जब तक लेफ्ट हमारा राइट से छोटा है या इक्वल है, till then you guys run it. Otherwise, once the left has become greater than right, stop this while loop. Okay, this is very simple condition. Once left is greater than right, stop the loop. Okay, that's the condition I put it. Okay, now because जैसे ये चीज होगी इसका मतलब वी हैव ऑलरेडी ट्रैवर्स एवरीथिंग. जैसे ही लेफ्ट जब भी राइट से बड़ा हो जाएगा, इट मींस हमने लेफ्ट को पार कर दिया है, राइट को पार कर दिया है. इसका मतलब हमें कोई एलिमेंट मिला ही नहीं. इट मींस गाइस, दिस व्हाई वी आर राइटिंग दिस कंडीशन. सी लेफ्ट विल स्टार्ट फ्रॉम हियर, राइट? ओके, लेट मी ड्रॉ दिस in the notes. Yeah, we do not need to reshare it. Like, see, this is 1 minute. Yeah, so this is 1, this is 2, this is 3, this is 5, this is 6, this is 7. हमारा लेफ्ट है यहाँ पर 0th इंडेक्स पे, हमारा राइट है यहाँ पर एट विच इंडेक्स 0 1 2 3 4 5 इंडेक्स पे. सो अगर हमारा लेफ्ट कहीं पे भी राइट से बड़ा हो गया, अगर हमारा लेफ्ट कहीं पे भी राइट से बड़ा हो गया, इसका मतलब है व्हाट डज इट मीन? इट मींस we have already covered all the elements from here, and now right has come this side. It means we have not find the element. It means we have not find the element. Correct? So that's why this condition I have written here, that if left has become greater or equal, so we will, like in equal condition we are saying go inside, but in the greater condition we are saying just simply return it. I will saying return -1. Return -1. Okay? Equal condition में हम कह रहे हैं कि ठीक है अंदर चले जाओ. मतलब there could be some scenarios where left and right at the same position, where left and right could be at same position, left or right could be at same position. तो उस कंडीशन में हम कह रहे हैं कि ठीक है चले जाओ लूप के अंदर. बट अगर जैसे ही लेफ्ट बड़ा हुआ, we are saying no, you cannot go inside the loop. Okay guys, are we good with this condition? Okay, so let's now this, like somebody was asking how can we calculate mid. This is the formula which we are using. See, people are using different formulas to calculate mid, but we are going to use this one, or according to our scenarios sometimes we change these formulas. So like first, like simply left plus right, क्योंकि हमेशा मिडिल ही देगा. Left plus right डिवाइड बाई 2, लेफ्ट प्लस राइट डिवाइड बाई 2। अब ये हमको जो है वो डेसिमल में आंसर देगा, इट विल गिव अस डेसिमल, बट वी नीड द फ्लोर आंसर, math.floor. Okay guys, I know you guys will be confused with math.floor. You know there is two methods which math library provides us. These methods are, you guys need to remember this thing, this is very good thing to remember. These methods are math.floor or math.seal. You know, in English we say seal and floor, right? In our home we say that, right? This is ceiling, this is ceiling, this is floor, right? This is ceiling, this is floor. That's what the similar method. So like if we are providing any decimal values here like 2.4, right? So math.floor will take the lowest one, like the nearest one to the lowest side, so it will always give us 2. In the similar case, it will provide the ceiling part, it will give us 3. It will take the our upper value, because 2 and 2.4 is coming between 2 and 3. So that's what floor will take the lower value and seal will take the maximum value. That's what the floor and seal does. And in our scenario, we are using the floor one, we are taking the minimum one. Okay, right, yes, that's right. Okay, so this is the way we calculate. And say, guys, I have seen somewhere like somebody is also doing this, right minus left divided by 2. This will also give you the same result. This will also give you the same result. I have seen somewhere like people are adding this number into left also, left plus, उससे क्या होगा कि हम लेफ्ट के आगे ही चल रहे हैं. I have seen some of the places people are using like this also while for calculating the mid. We are just like what does it mean? Like whatever value is coming, add it into the left. Add it into the left. But yeah, we are going to take the simple one. We'll start with the simple one, then we'll see the different scenarios. Correct? Now once we find out the mid, what was the second condition? What was the second approach? जैसे ही हमने उसका अपनी बुक का मिडल वाला पेज खोला, we need to compare. So now we'll compare if array mid, मैंने बोला था mid left right ये तीनों इंडेक्स होते हैं, mid left right all three are index. So first we'll compare if mid right is equal to target. If this is the scenario, we'll simply return the mid, simply return the mid from here. अगर ऐसा नहीं है, we'll put our condition here, else if. अब हमें क्या कंडीशन करनी है? अब हमको लेफ्ट साइड जाना है कि राइट साइड जाना है? We have to decide that. So for that, array mid हमारी कंडीशन क्या होगी? less than target, और else by default, क्योंकि सॉर्टेड है, एरे सॉर्टेड है, या तो लेस होगा या फिर ग्रेटर होगा अगर वो सेम एलिमेंट नहीं है, राइट? तो अब देखो, अगर हमारा एरे मिड लेस देन ए टारगेट, अगर हमारा एरे मिड लेस देन ए टारगेट, तो आप हमें बताइए क्या करना है हमको. टेल मी इन द चैट व्हाट वी नीड टू डू. गाइस, if our mid element अगर वो लेस देन है टारगेट से, तो हमें क्या करना है? if our mid element is less than target, what we have to do? We have to go which side? We have to go to the right side, क्योंकि हमारा टारगेट बड़ा है. That's right, we have to go to the right side. अब हमें राइट साइड करने के लिए क्या करना है? हमें राइट को टच नहीं करना है. अब देखो, इन दिस केस, इन अ सिमिलर केस, गाइस 1 2 3 4 5 6, ठीक है. अब हमारा मिड एलिमेंट हमने माना कि ये था 0, हम इंडेक्स भी लिख देते हैं. हमारा मिड एलिमेंट इज दिस 3, विच इज, हम टारगेट है हमारा 5. हमें पता चला कि हमारा जो मिड एलिमेंट है, इट इज लेसर देन टारगेट. So what we need to do? We have to go to the right side. we have to go to the right side, correct? But in the right side, we do not need to touch the right index. Right index is the right place, but we need to touch the left index. And now we will make our left index to mid plus 1. Mid plus 1. And it will start from this index. So that's what we are going to do, guys. Left is equal to mid plus 1. So guys, this is no need to remember. You guys can play here. Like you can put left is equal to mid also and then check what is happening. Okay, some of the places you guys can take 1 also here. You can take array dot length like this also. You guys can play. It is not like that I am telling you to use this way, so you guys just remember this way. No, you guys can play according to this. Sometimes I have seen people are taking left -1 and then they are going array dot length also like this, right? So guys, it's not like that. You just need to remember like this. However code am I writing, you need to remember like this. No, you guys can play around this code. You guys can change values. You guys can check the values there. It is working or not. Okay, I will suggest you guys to do these things. Okay, so now this is the scenario. This is the scenario when our mid element is lesser. When our mid element is lesser than target. But what is up? What in the else case? If our mid element is greater, अगर हम यहाँ पे हमारा टारगेट 2 होता, अगर हमारा टारगेट 2 होता in same scenario 1 2 3 4 5 6, our target is 2 and our middle element is this 3 0 1 2 3 4 5. ये indexes हैं. These are indexes. These are element. Correct? अब अगर हमारा मिड एलिमेंट 3 होता जो कि हमारे टारगेट से बड़ा है, राइट? हमारे ही टारगेट से तो बड़ा है. अब हमें क्या करना है? अब हमें लेफ्ट साइड जाना है. विच साइड वी हैव टू गो? लेफ्ट साइड. जब हमारा टारगेट बड़ा था मिड से, हम राइट साइड गए. अब हमारा टारगेट छोटा है मिड से, हम अब लेफ्ट साइड जाएंगे. तो इस बार हमें लेफ्ट को नहीं टच करना है. इस बार हम लेफ्ट इंडेक्स को नहीं टच करेंगे. इस बार हम राइट इंडेक्स को टच करेंगे और उसको हम माइनस करेंगे. So that's what in the else condition, guys. In the else condition, we will minus the mid one, mid -1. क्यों माइनस कर रहे हैं? क्यों माइनस कर रहे हैं? Because mid right now is at 2 second index, but we have already figured it out. This one we have already tested. This one is not equal, less than. So हमें अब यहां से चेक करना है, इसलिए हमने अब राइट को हमने यहाँ पे ले आए. अब हमारा राइट यहां से चलेगा, हमारा लेफ्ट यहाँ चलेगा. अब फिर से हम मिड को फाइंड आउट करेंगे और हम बहुत चीज चेक करेंगे. अब हमारी जो दूसरी बार कंडीशन चलेगी उसमें मिड होगा लाइक 0 + 1 डिवाइड बाई 2, 1 by 2. दिस वुड बी 0.5 और हम 0 लेंगे. लाइक दिस इट विल गो. करेक्ट? नाउ वी विल चेक फॉर 0 एलिमेंट. नाउ वी विल से नो, इट इज ग्रेटर, वी विल इंक्रीज इट. Correct? So now see guys, that's how we will do. And let's first, I will show you all the values, how it is looking. Let's run this one. Let's see this is working or not. Okay, let's see this is working or not. So our target is 18 and our index should be 0 1 2 3 4 5 6 7. Our target should be 7. Correct? Let's see, is it giving us or not? Node, yes, it is giving us 7. Now guys, let's take a because this is bigger one, let's take a small input like which we are taking here. Yeah, 1 2 3 4 5 6. Let's take this one, 3 4 5 6 or 7. We can like, it should not be like we are just writing everything like this. This is small, 1 2 4 5 7 9. And now we are looking for, let's look for 3. Are we getting -1 or not? Yeah, you can see -1 is there. Correct? Let's look for 2. We are getting the first. Okay, this is how it is working. Now what I'm going to do, I think we are already at the end of class, but now what I'm going to do, I'm putting one console. So we'll see how the left and mid values are coming, and I will put it at the first place and then at the end place. So I will put it here console.log. I will put it as a start, and we can put it like left, mid, right, like this. Correct? And then we will put it at the end also, because before going for next iteration. This is how we understood, right, these things, right? Now we'll put it here. Now we'll see our console for the same example where we are looking for 2. Okay, let's see. Okay, guys, you see, the first time our left was 0. That's right. It's the first iteration. Left was 0. Correct? Mid was 2 and right was 5. Right was 5. That's true. Now 0 plus 5 divided by 2, which gives us mid as 2. So that's right. That's why you can see 0, 2, 5. 0, 2, 5. करेक्ट 0 2. अब देखो हमारा मिड क्या आया 2. हमने यहाँ पे कंपेयर किया एरे 2 इज इक्वल टू टारगेट एरे 2 जहाँ पे 4 है हमारे पास. हमने कहा नहीं, दिस इज रॉन्ग. then I went for this one, array mid less than target, array mid है 4, is it less than 2? नहीं, हम else वाले पार्ट में गए. हमने क्या किया, right is equal to mid minus 1. हमारा mid क्या था 2. You can see in the console mid was 2. Correct? So what I did, mid minus 1. You can see in the next iteration 0 and right has become 1. Earlier right was 5. Now it has become 1. And then what we did, 0 plus 1, and which the same thing, 0 plus 1 will give us 0. Then we again looking array 0 is equal to target. We said no. Is it greater than target? We said yes. Then what we did, left is equal to mid plus 1. Mid हमारा 0 था, हमने उसको प्लस 1 कर दिया. अब तुम देखो यहाँ पे देखो जैसे ही नेक्स्ट इटरेशन में आए सब कुछ 1 हो गया. मिड भी 1 है और राइट पहले से 1 था, हमने अभी लेफ्ट को भी 1 कर दिया. तो 1 plus 1 डिवाइड बाई 2 फर्स्ट इंडेक्स, और जैसे हम फर्स्ट इंडेक्स पे आए हमको टारगेट मिल गया. Okay guys, was it difficult? Let me first commit the changes. Yeah, now the changes are available in the file. Let me provide you the repo also. Yeah, this one, right? DSLGO.js. No, not this one. What was the name? Yeah, DSLOG. Yeah, I have pasted it. You made it easy to understand. Thanks, Vishal. With recursion. Yeah, with recursion, we'll see that. See, in the recursion, see guys, you know what will happen in the recursion? I think the same code in recursion, we have to call the similar thing. So I think first we need to decide for our base condition, and our base condition would be similar, left, right. We need to pass, I think we need to pass 2 more things from here, left, right. हमें ये 4 चीजें फाइंड आउट करनी पड़ेंगी और हमारी बेस फिर से वही कंडीशन होगी यहाँ पर. अब हमारी जो कंडीशन होगी ना वो ये होगी, इफ लेफ्ट वही लेस देन इक्वल टू राइट. और ना यहाँ पे इक्वल नहीं होगा, यहाँ पे सिर्फ लेस देन होगा. अगर ये हो जाता है तो इसका मतलब हमें कोई एलिमेंट मिला ही नहीं. वी हैव नॉट फाइंड एनी एलिमेंट. दैट मींस दिस इज द रिटर्न -1 केस. And before that, I think, yeah, if we find that element, I think we need to find it out the mid also. I think we need to pass mid also here. Yeah, somehow we need to pass the mid also. And then I think we will do like this, array mid equal to target. We'll return the target, we will return the mid from here, return mid. And then the second condition would be this, if left less than right, तब return करो -1. And now we'll calculate the mid. So let mid, same way, let mid is equal to math.floor. I'm thinking, like I'm quickly thinking, I think this could be work. Left plus right divide by 2. Divide by 2. And then I think we might be having another condition here. Like if array mid less than target, then we need to call the binary search again. Like this. Binary search again, same array we will pass, but this time it is less than. It means it is the less than, right? Is it less than the target? It means we have to go to right side. It means left will be mid plus 1. Correct. Left will be mid plus 1. And I think then we do not need to pass the mid. Guys, I think then we do not need to pass the mid here. And in the else condition, something like that, it should work, guys. You guys can just, I will paste this thing. You guys can test it. And this time it should be, left should be same, but right should be mid minus 1. Mid minus 1. Correct? And this mid should be calculated first. Here. Yeah, I think this could work. Okay, so I'm just committing it so you guys can look into this one. Recursive approach. Okay, let's come back to queries. Yeah, it was my understanding. Thank you. Okay. What about the element if not present? Yeah, if the element is not present in the earlier case, it will return as -1 because left and right loop will fully run Parag. Yeah, that's right. Let's see very quickly what is left in slides. Okay, so the complexity for this, guys, as you can see, we are just making it half, and then we are again going into, like, we are just doing every time half. Every time, whenever we are getting new sets, we are just breaking it into the half. So the time complexity for binary search is log 2n. Log 2n. Because if there is 16 element, so log 216 is 4. 4. So in the 4 iteration, we might be getting the result. Yeah. I think we can discuss about this in the next class also. But yeah, I think we can stop it here and I can answer your queries. Line number 32. Riyaz is saying line number 32. Okay, let me see line number 32 quickly. Line number 32. If left less than right. I'm not sure about it, but left less than right. Yeah, I think that's condition is correct, right? Left will be always less than right, right? Yeah, I think, yeah, that condition is correct, right? Oh, okay, okay. 1 minute. Oh, yeah, yeah, yeah. It should be greater. Okay, okay. I got it. Your point. Okay. Once left is greater than right, then it should return -1. Oh, yes, yes. Thanks. Thanks. Yes. Yes, that's right. That's right. Vishal is saying, but if mid should be passed as it was parameter. No, actually, we will not pass mid. I think not needed. We will calculate the mid here in the recursive approach. We'll calculate the mid and then we will check these things there. Okay. So target is found, it just returns to above recursive calls, right? Target is found, it just return to above recursive calls. Yes, yes. Okay, yes, yes, Joseph. I've shown you a slide, right? This slide, right? Yeah. Yes. So once the target is found, you can see all the recursive functions just return the same result to the previous function, whoever has called. That's why we're writing return in the functions. So it just returns to the previous one. And then again, the previous one return to the earlier previous one. That's what the recursive means. Okay. So yeah, I think that's all for today, guys. I know these concepts are a little bit tough to understand, but yeah, I think because you know now the approach, so you just need to do practice now. So please try to play with this binary search, try to change the variable's name, try to change the variable values, like trying to change the left values, try to change the right values, try to put something in the right, try to change the conditions, and then see how the result is coming. Yeah, recursion is definitely, it's tricky. Right, right, right. I think if you talk about the binary search only, so I have seen like a lot of questions you can solve simply through the iteration. No need to go for recursion. Return and non, see, if you are returning something Likit, so from where you are calling, that particular thing will be returned, right? See, okay, that let me show you very quickly. See, like let me tell you first verbally, return means a function is returning something. Non-return, it means that function is not returning anything. It is just doing things internally. Like a function likha, you write one function, you are adding something into that, inside that function, but you're not returning the result. So it means it is a non-return function. Correct? It's not returning anything. And return function is once you add those number, you are returning that number here. Let me show you if you have still confusion on that. No problem. See, very easy example. Create one function add return added here const result equal to 3 plus 4 and then return result. Console it out. Console.log add 1. Let's create another function. Function add 2. But do not return anything. Do not return anything. Put the another console 2. See the difference now. We'll see the difference now. Note binary. You see, first it is giving us 7, second one is giving undefined. That's the difference. If you will not return anything, it will give you undefined. That's why in the recursive, we are always returning things. Otherwise, it will give us undefined. Okay? That's the difference. Okay, Likit? Did you get the difference now? Great. So yeah, I think guys, we'll wrap it here today and we'll connect tomorrow morning to see the further things. Okay. Thanks. You guys liked it. We'll talk a little bit more about it. And after that, I think you have Saturday and Sunday, whole Saturday and Sunday. You guys can do more practice then. Okay. Yeah. Very good night, everyone. Okay. Okay, everyone. Have a good night. We'll talk tomorrow. Bye-bye.